Good morning, everyone. If you can hear me, type in good morning. LJ, good morning. Anna, good morning. Edric, ignore. Bardia, good morning. Christopher. Spencer, Michael, good morning to you as well. Samuel, Kelly, good morning. Risha Ranjit, what is up? James, how are you? I'm hoping you have breakfast. I've got a nice cappuccino next to me. I just took a sip, just starting to gear up for the big session today. Jaspreet, what's up? We've got an exciting session again today. I hope you realize I was saying the truth at the very beginning. Every minute is action packed. Satrikal Shivam, good morning, everyone. All right, so what the hell are we doing? Well, here's what we're doing. Let's touch base and have a look at our main document. We're going over an important division. I carved this course into three parts, roughly equal, but the first parts, it gets a little longer because the skills require, I think, an extra week each one. And so we're entering month 2 now. So let's have a look at our main document. We'll do that first. We'll review our terminology also. If you remember at the very beginning, when we were learning our connectives, they each have names. We know those. But the parts that are related by the connectives, the parts that are connected by the connectives, each have names as well. And so we'll be talking a lot, and you'll see this throughout today and next week. I'll be talking about these arguments in a tactical manner, and I'll need to pinpoint different parts and so on. So I'll be repeatedly using this terminology. So we need to be clear on what it is so that we understand each other, because there's all these fine-grained distinctions that we need to be able to make. So I'll do that. This is a file that's available at the top of our Moodle page, but I'll go over it carefully. And today we're learning truth tables. So remember, this course is sort of, the mindset is, well, if I was giving you a crash course in, let's say, lifting weights, I'd probably train you how to do squat, bench, and deadlift, the 3 power lifts or something like this. Well, if you think of this as a crash course in formal logic, it's an introductory course. We can't do everything. We're not going into the finer details. It gets way, way, way more complicated than this. But what are the basics in my estimate? Well, symbolization, truth tables, and derivations, also known as proofs. And so we're learning our second one of those today. We're starting out, we're going to spend a month on that. And I want to remind ourselves what the goal was, because we saw this earlier. There's a real need for the tools that we're requiring. And the goal is to verify and extend our thinking. If you remember, there's some arguments quickly become beyond the scope of what we can fathom, and we need to give ourselves the tools to understand that. We've started doing that, and it's nice and cumulative in that sense. The skills you learned last month enable you to understand what's the goal of what we're doing this month and next month and so on. So it keeps building up. And then what I'll do is I'll give you some preparatory concepts that really, really are important, and I've tried to make as accessible and less scary as possible, because I've been teaching logic for a couple decades now, and I know sort of what works and what doesn't, and I've got a nice bag of tricks that really helps to make it less scary. So I'll talk about Russian dolls, easy zoology, law of the jungle, and we'll go over that. And then those are going to be sort of all the materials that will allow you to test for perfect plumbing. You're going to become plumbers this month, and we'll check for perfect plumbing. Nice analogy. You'll understand what it means in time, but we'll check for leaks. Basically, it's going to be a jam-packed class. So it's going to be, again, I'm trying to make this as least scary as possible. It doesn't get much better than this. But again, I can't do it on my own. So I need to make sure that everyone's there and alert. You got your food, you're willing, you rolled up your sleeves. I rolled up my sleeves, not metaphorically, I literally rolled up my sleeves. So does that sound like a plan, my friends? Everyone good to go? If you're good to go, type in GTG. Good to go. I'm good to go. I'm stretching. You're good to go. That sounds great. All right, let's do this. Let's have a look at our main document. It's nice to be able to tick some items off this list here. So drills, that's all done. Well, you did 10. That's an easy 10, right? Because you just had to actually practice. You had unlimited attempts. So that's 10. That's terrific. You scored some points there. Test 1 on symbolization. That's done. That's out of 20. What was your performance? Don't know, don't care. We're adopting a forward-looking perspective. Right now, our sights are on test 2 on truth tables. You will have one quiz this month, which will be a smaller scale version of what you will have as the test on truth tables. It shall be worth 10%. And that the goal is that if for whatever reason Well, I want to get your heart rate up. I want to give you an incentive to work hard, and you never quite know until you compete. I used to compete in sports, and I had a friend who used to say one competition is worth 40 practices or 40 training sessions. And I think he was right, because there's a different mindset on game day. It matters more. And so you're going to have a quiz, and if you do well in the quiz, you're on the right track. If you do poorly, you have room to adjust, and it won't hurt you as much. And remember that I will keep, when it's all said and done, only your best 2 quiz results. I will hold 3 quizzes throughout the term. You'll get 2 when we're doing a month 3 and we're learning derivations. You'll get 2 quizzes in preparation for that, because that's a slightly harder skill. So be smart. Aim for 10 out of 10 with these quizzes, and that's going to be on February 13th. So that's in 2 weeks. Things are going to move forward. All right. So speaking of weeks, let's have a look at our week by week breakdown. Here we are. Month 1, symbolization. 1 and done. That's terrific. We did it. So remember, our first month is symbolization. We've done that already. That is done. Let's scroll down over here. Second month skills, truth tables. This week and next week essentially is when we're going to learn all of the month's skills. So just to be clear, this week we're learning a new skill. The next week we're going to learn a more difficult skill that, again, there's a reason why it comes after, presupposes that you've mastered what we're learning this week. So it's crucial. I'll underline it 3 times, that you do your truth table homework this week, because next week, right, when I start class, I'm assuming you've done all of that. I'm going to hit the ground running, right? And it's what we're going to do essentially is go in reverse, right? So you can imagine if you're driving a car in reverse. Imagine I have to have you drive around Surrey in reverse. You need to be able to drive forward before you learn how to drive backwards. Or if you want to take another analogy, before you can moonwalk, you need to be able to walk, right? And short truth tables are going to be kind of what we're doing this week, but in reverse. So it's going to really require you to understand it. And once we're done with these 2 classes, so class number 4 and class number 5, we'll have learned basically all of the skills that we need for this month. The rest of the month is going to be devoted to just practicing them, because they require practice, and I'm expecting some fine tuning and so on, right? So the 2 weeks after that, so 2 weeks from now, we'll have our first quiz, and then what we'll do is we'll stop. I'll put the quiz in the middle, so we'll sort of touch base, practice a bit, hold the quiz, and then right after the quiz, we'll get back in class and practice again. And we'll do that again. Unfortunately, we don't have a reading break. We have the reading break, so we have no class, right? But the idea is to prepare you as much as possible. And the reading break, by the way, is not like a drinking break. It's a reading break. You're supposed to practice. And so I'm expecting that throughout all of this time, you're doing homework, right? And by the time you get to test 2 on truth tables, you'll do well. If you do everything I tell you to do, you should do well. Notice that's worth 25%. So the weights of these things are increasing a little bit, right? So that's going to take up all of the month of February. So we're going to have a busy month, and then we'll transition to an even harder skill, which will be derivations, and which will presuppose a lot of the stuff that we've done before. And so let me just pause right now, looking at the week by week breakdown. Is that clear, everyone, or do you have any question? If everything is clear, type in clear. If you've got a question, ask your question. So here we are, January 30th. If everything's clear, type in clear. If you've got a question about our schedule and so on, go ahead and ask. I work extra hard to make these schedules. It really pays off, I think, in the long run, right? So it's nice to be able to have a blueprint, because I'm certainly spinning a zillion plates and I can't hold it all in my mind. All right, so, and remember, I'm going to read this advice again. No, Edric, there's no time to discuss the test, because the grades for that can't change, and we're moving on. So let's say whatever it is from now on, and you'll see this, and this goes back to let's have a look at the week by week breakdown. I said this at the beginning of class, and this is something that's really going to be apparent this class. We're transitioning away from English. So from this point onward, so here we are beginning month 2, there's no more English. We're going to let go of English. We spent all of this first month transforming English into symbols. From now on, there's going to be no English. There's a few little remainders today, and that is it. We'll never see English again, and we're moving on to something else. So this skill is a ladder that we can discard. It took us to month 2 so that we understand what our symbols are about, but we let it go, right? So we're going to just move forward and keep going, because there's no real point in dwelling in the past. So that said, if you do, for whatever reason, want to discuss the test, maybe next week we can do that. But I'd rather spend every minute on sort of making sure you do better in the next test instead. Edric, does that answer your question? Because I'm looking at the clock and like every minute is vital. Like we're going to do so much right now. And I really don't want to waste a single minute. All right, so here's the word of advice. I'm going to read this again because cool. I'm going to read this again. This is super important. Let me zoom back out a bit. Repeated practice is essential to success in logic. If you just look at the screen passively as if this was YouTube, then you will fail. Even if you indulge in that laid-back approach only once. Indeed, falling behind by 1 week can derail your whole term. So do all the homework that you're supposed to do the week that you're supposed to do it and never miss a class. To form a realistic picture, averages in philosophy courses tend to hover around 68%, plus or minus 2. Naturally, the statistic does not imply that you will get this numerical result. Logic is even harder. I grade your answers, not your life, so don't give me sad stories or expect second chances. This course has been carefully engineered to maximize student success. But if you're lost, if confused or unsure about something, ask me for help beforehand, since after that, well, as I just said, nothing can be done. This is a unique opportunity to exercise your brain and growth, so make the most of it if you put in the work, which I cannot do for you. I promise that I will do my utmost to help you perform at your best. So remember, we have a deal, right? There's my end of the bargain, there's your end of the bargain, and if we both do it, then what we're going to breed is success to the extent of, circumstances and your ability and so on. But I really want this word of advice to sort of repeat it again. If for whatever reason it took you 1 week, 2 weeks to get into gear, and you suffered, look, today is the first day of the rest of your life. Just pick yourself back up. Look, I don't know and I don't care, right? But definitely, I'm telling you right now, you cannot afford. Look, go back to the week by week breakdown. You cannot afford. I repeat, you cannot afford to just kind of sit on your butt and do nothing this week, and then finally kind of wake up somewhere around here or worse still later. You'll be totally screwed this month. And you have to spread out your work so that you sleep in between, so that your subconscious can process these skills, because they're going to require you to dream about them. And so a little bit every day. All right. So that's the advice I give. If you follow that advice, and it comes from a place of love. All right. Is that advice clear, everyone? If that's clear, type in clear. If you've got a question, ask your questions. I really do want to say that again. I took the time to write this carefully. And it comes from a place of love. I want to see you succeed. But it is a homework intensive course, practice intensive. Type in clear if that's clear. It's tough love, yeah, but it's lots of love. I'm a dad, right? Same thing with my kids. It's sometimes when you know it matters, you don't want them crossing into the street when there's traffic, things like that. You hammer on those lessons hard. Because the consequences are significant. Let's review our terminology. Here's a negation, and as we know, negation is our one place connective. Most of the connectives are two place connectives, and even if it's a one place connective, that makes it a compound proposition. And a compound proposition is one that has within it at least one or two atomic propositions, right? So that space over here, right? That's the atomic proposition. We call this the tilde sign, and these are the truth values, T and F, standing for true and false. This is our conjunction. Both sides are called conjuncts. So the left-hand conjunct, right-hand conjunct, right? So we need to be clear about that. This is called a column. This is called a row. This is going to be crucial because we'll be building tables today. So when I refer to columns, I mean what's vertical. Actually, this is a mistake. I should say here, that should be horizontal and vertical. So I just spotted a typo. Cool. I'll change that. But columns and rows, we know what we're talking about. Disjunction. Left-hand disjunct, right-hand disjunct. Conditional. This is called the antecedent. This is called the consequent. An equivalence. This is the left-hand constituent or right-hand constituent. For this one, I'll sometimes say what's on the right side of the equivalence or what's on the left side of the equivalence. And that's our terminology. Any questions about the terminology? If everything's clear, type in clear. If you got a question, ask your question. Just a kind of reminder. I'll go over, and this file's available. I've just noticed a little typo that I'll clean up, but it's available on the top of the Moodle page. So if you ever want to have a look at this again, okay, cool. All right, let's do this. Remember, truth tables, there's a reason why we do what we do in class, and it's a reason that I tried to lay out from the very first week. And the goal is to verify and extend our thinking. The argument I started with was a fairly long one, right? If I take his pawn, then either he will take blah, 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 blah. And we end up with this conclusion, right? Either his queen or mine will be exposed. And it's not obvious what the conclusion should be. If you just look at the premises, it's rather confusing. And suppose someone says this conclusion, it's not clear whether, in fact, it follows from the premises, right? Small arguments, we don't have that problem, but very quickly we enter into a realm where our brains and our minds sort of fall short. And so structurally, because this is, of course, in formal logic, when we start to parse an argument like this into its constituent atomic propositions, we notice that some of these propositions recur and so on. So here, right, if P, I take his pawn, then K, right, he will take my knight, and so on. And once we look at the structure, that allows us to realize that formally, even though this is an argument about chess, it can also bear the same structure, identical structure to another argument. Here has to do, P stands for I signed the petition, and so on. Both arguments are identical. So one of the merits of transitioning from English to symbols is that you don't need the English anymore. And moreover, by getting right on the structure, you're getting right on all of the different English language arguments that might actually have that structure. And it's also getting to a universal language. Like this could easily be an argument in Punjabi. I don't care, right? Once we get to the structure, it's identical, right? So once we translate everything into symbolic logic, whatever would be the original language that we started with, whether it was an argument that was originally stated in English, that was stated in French, that was stated in Punjabi, in Mandarin, or whatever, once we get to the structure, right, we really can now discard all this natural language and let it go. And that's good for us. And here we have sort of a midway step where we've sort of started reducing all of these atomic propositions to just some capital letter, right? And there's another step now that we've learned our connectives. Now we can also replace the connectives with symbols. And we have the same argument, whether it's the argument about petition or about signing a petition or about the chess, that's the same argument. And we've also learned, and we did this in the test that we just did, when we symbolized this, we put this all on one row, and we were using our single slash and our double slash over here to separate the premises and to separate the conclusion from the premises. And the question we want to ask is, well, at a glance, it's not obvious. Now you know this is not gibberish, right? The symbolization, the first month consists in my showing you that this is not a course in algebra, right? This is not gibberish. This is not pulled out of thin air. And now the interesting question is, well, does this conclusion really follow from these premises? This is the question now we want to be able to verify. So the first month was all preparatory stuff to get us to be in the position where we can answer that question. Does this conclusion actually follow from these premises? And it's not obvious. And if you think it's obvious and you've got it figured out, then you need to back that up. So suppose you say, yeah, it does. Okay, fine. Why? Prove it, right? How could you back that up? And these are the skills that we want to be able to acquire. And that's extremely valuable in a host of domains, right? It's just getting your reasoning right. I'm a philosopher, so for me, these are I sort of turn this tool to help me in trying to answer and make progress on what you would call the big questions, but I don't care what your interests are. That's a valuable skill to have. Now we want to ask, does the conclusion actually follow from the premises? And that's what we'll learn today. Is that clear, everyone? If that's clear, type in clear. If you got a question, ask your question. Got myself a bite of oatmeal. So on that note, let's say almost bye-bye to language now. Almost going to be all gone. So let's give us some preparatory tools here. Russian dolls, easy zoology, and law of the jungle. All of that will make sense. And there are just ways of me talking about things that are going to be useful in a way that's not scary and that is memorable. So let me open up a Word file here. I'm going to work from a Word file. Let me set that up. Here we go. Share screen this. What do you see on the screen right now? Confirm that you can see that. Type in what you see. Cool. Everyone can see that. All right. I love this monkey. It's really cool. Do I want to say it's a baboon or a monkey? I wouldn't even know. Can everyone see which word I've selected here? Type in the word I selected. Splendid. All right. So I want to make sure we got our tools visually at our disposal, that everyone can see this well. All right, so the idea is our minds are very limited. As you saw a moment ago when you have arguments, and I stopped arbitrarily at one page. Huh? You can have an argument that is much larger. An entire book is in some sense an argument, broken down into sub-arguments. Our minds are very limited. Very quickly, we're unable to grasp not just arguments, but all sorts of other things. Let me give you an example. How many bars are there on the screen right now? How many bars do you see? Black bars. Yeah, two. Right? Two. One, two. Cool. How many do you see? Six. Yeah. How many do you see? Not infinite. It's a finite amount, but a lot. And all of a sudden, it's taken a while, right? No one's like, there's a change at some point, right? Do we agree? Like if you backtrack, right? What did I do? So this was fine. This was fine, right? Whatever this was. And at some point, it's like, this is not fine, right? Like here, we're entering into a range where we got problems, right? Because our minds are very limited. So how do we deal with this? Does anyone know Roman numerals? Say yes if you do, no if you don't. Roman numerals. Well, if you think of Roman numerals, I'm glad most people know. I mean, if you know what it is, you don't have to know them all. Roman numerals. Type in the chat bar. What would be the Roman numerals for 3? Yeah, you got it. So 1, 2, 3, right? And if you say, well, here's the Roman numerals for 3. How many signs do we have on the screen right now? So how many symbols are we using? 1, 2, 3. So we're trying to pick out 3, right? Is this, answer yes or no, is this the Roman numeral for, let's say, whatever number this happens to be? Yes or no? Like if I want to say how many lines are there, would this be the Roman numeral for this number of lines? Yeah, you're absolutely correct, right? That's not the right one. So this is the Roman numeral for 3 is 3 little lines. What happens if I want to say 4? What would be the Roman numeral for that? Would I just add one more line? So the Roman numeral for 4 is not this. The Roman numeral for 4 is, as you point out, this. Why? How does that work? So what's IV? How does that work? Very briefly, how does that work? How's that 4? That's right. Samuel says it's 5 minus 1. 5 minus 1. So this is 5. So this V over here, that stands for 5. And anything that ends up being on the left-hand side is minus it. And here it's minus 1. So 5 minus 1 makes 4. So that would be 4. Let's just go over here for a second, right? Oopsie, that's not what I want to do. Here I had how many symbols I was using. It was a ratio of, I had 3 symbols that I was using to express, right, the number of bars, right? So suppose I want to express the number of, this is the object I want to count. This is the number I count it with, and I end up using 3 symbols for it, right? If this is the number I want to count, and this would be the number I would use to count it, how many symbols do I have in the Roman numeral 4 over here? 2. 2. All right. Suppose I want to count this. right? And this is 5 now. What would be the Roman numeral for that? Yeah, just a V. And how many symbols would I be using? Just one, right? What about 6? 1, 2, 3, 4, 5, 6. In Roman numerals, what would it be? V and I. And how many symbols am I using? 2. What about 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's X. How many symbols am I using? Just one. Suppose I want to do 1, 2, 3, 4, 5, 6, 7, 8, 8. What would be the Roman numerals for that? 5, and whatever's on the right add. So 5, I. How many symbols am I using when I write in Roman numerals? 4. No matter what you do, suppose I let one more example. If I want to do 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Roman numerals, please. X, I. How many symbols am I using? 3. Right? No matter what you want to model, no matter what you want to count, you transform it into a sign that is more compressed, that never is sort of spills out beyond 2 or 3, sometimes 4 signs visually. Like, how do we do 9? So this was 8, right? How do we do 9? Would it be like this? What would be 9? That's right, it's this, right? So that would be 9. And once again, I would have how many symbols? 2. So you never get past our very limited cognitive range, which if you do some cognitive science, right, is 7 plus or minus 2. We're at most capable of grasping 7 plus or minus 2 things, right? That's why earlier when I started and I said, how many bars do you see? We did okay with this. We'd be probably okay with that. But once you get over 7 plus or minus 2, so maybe if you're a genius, you can get 9 at a glance, right? If you're a little more struggling, it'd be like 5. But either way, you hit a limit, right? Like the difference between like someone who's good at what's called subitizing, this is what it is. So seeing like at a glance, right? There's a limit. It's like beyond that, it's like just a lot, right? Like the answer in the chat bar, Kelly and friends were saying just like many, right? That's how we are. But what we do is we use notational devices, in this case, Roman numerals, to compress and transform something that allows us to extend beyond our cognitive range. So this has, for instance, this is 13 or 12. There's 12 bars there. We can't grasp 12 bars because that's over 7 plus or minus. If I had to put 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say there are 22 bars. How would I express this in Roman numerals? 22 bars. What would be the Roman numeral for 22? Yeah. XXII, which would be, again, just 4. So notice all of these. This is within 7 plus or minus 2. That's within our cognitive range. We can reduce all of these complicated objects always within our cognitive range thanks to a gorgeous little system of notation, these external signs that we've devised for the purpose of extending our stupid brains. That's a cool trick to learn. When the Romans did it, they were able to build aqueducts and cool things followed. Well, I'm going to teach you a cool trick that's going to allow you to extend your cognitive range beyond what you can currently fathom so that you can wrap your mind around complicated arguments like the one I showed you earlier. So there's a brief philosophical / cognitive gloss on what the hell we're going to do and why it's cool. My friends, is that clear, everyone? If that's clear, type in clear. If you got a question, ask your question. At no point are we going to get beyond 7 things. In fact, look, I said 7 plus or minus 2. This is such a sweet deal. I'm going to teach you a method where we never, at any given time, get past 3 things in your mind. I mean, you can grasp 3 things, right? No matter what happens this month, you're going to break things down into bite-sized pieces. And at any given time, you'll never be required to think of more than 3 things at once. So not only do I not care where you happen to be on this range of, let's say, 5 to 9, you so don't need to be a genius to be good at logic, because the tricks I'm going to teach you are never going to get past three things. So keep that on a shelf. You'll see that in practice by the end of the class. All right, so let's go back to our connectives that we know and love. We have an atomic proposition. Look, it says something. It's making a claim. It says it's not the case that whatever, right? It's not the case that the Loch Ness Monster exists or something, right? You negate something. And that can either be true or can be false. Maybe I'm wrong, right? Maybe there is the Loch Ness Monster, whatever. So those are the two truth values for this proposition. And our negation sign simply flips it around. And we had more complicated two-part connectives. So here's conjunction, right? Suppose one of the left-hand conjunct is true and the right-hand conjunct is true. The whole conjunction would be what? Exactly, true. And these are the drills I've been having you practice. Suppose the left-hand conjunct is true and the right-hand conjunct is false. It would be what? Good. You see how that's happening fast now, which is good, because 3 weeks ago that was a little new, right? And you had to commit that to memory. Suppose the left-hand conjunct is false, the right-hand conjunct is true, the whole conjunction is false. And suppose both conjuncts are false, then the whole conjunction is false. And I'm gratified by the speed at which I've seen these F's and these T's appear in the chat, because that means you practice your drill. That's the wax on, wax off. So not only do I use the Karate Kid to show a nice relation between apprentice and master, but I use it because there's that whole idea that he makes the apprentice do a lot of what are seemingly stupid drills that end up being ridiculously beneficial for him later on in acquiring his skill. Well, you'll see that later on. But what we can do then is there's no reason why. Like, let's go back to negation. Negation was negating whatever, right? The P stood for whatever. Well, you can negate whatever, and the whatever can be, let's say, a conjunction. You can totally have a situation where I negate a conjunction. I would say something like, it's not the case that blah, 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 and blah, blah, blah. I'm entitled to negate the entire conjunction. I'm not just negating the individual conjuncts. That would be different. I'm negating that both things are going to be the case, right? And if I do that, what I do is I just refer myself to the truth values I have here. And those truth values you have in this particular column reflect the entire conjunction. That was the convention that we've learned last month. So we put them in the middle of the sandwich. And that stands not for P, not for Q, but for the entire conjunction. And so if the negation is the old flipperoo and this was true, what do you think I should put here? False. Just switch the truth value around. And if here the whole conjunction was, in this situation, the whole conjunction was false, what should I put here? True. Exactly. And likewise here, I put true. And likewise here. Right? If this was false, then I put true. So all negation does is it negates. But what does it negate? Well, it negates whatever happens to be in that spot. Earlier I said that negation is this. It's not, and then I said whatever you put in here. When I say whatever you put in here, it doesn't mean just an atomic proposition. It could also be a compound proposition. You could easily put in that space a compound proposition and just negate that, right? And that's exactly the situation we have here. We have a compound proposition, in this instance, a conjunction, and it's being negated. And so we end up with these truth values here. And the truth values in this column now are reflective not of P, right? Not of the and, not of the Q, but of the not, and not what? Not all that. It are reflective of all of this. So this column is the truth value for this very compound proposition, right? Which is not P and Q. Let's backtrack a little bit. This easily could have been also the negation of a disjunction. So let's imagine I have a disjunction, right? Like, we're going to redo these over here. What would be the truth value of, I would put here? I put true, exactly. What would be this truth value? I'd put true. What would be this truth value? True as well, exactly. And what would be this truth value? False, yeah. When both disjuncts are false, then the entire disjunction is false. So now let's have some more fun. What would this be now? It would be false. And then this would be false. It stands to reason this would be false. And the final one would be what? Over here? The old flipperoo? And notice what I'm negating. This is not negating this. This F is not negating this truth. There's all sorts of T here. It's negating one particular truth, namely the one in the middle, because that's the one that's representative of this entire disjunction. And this is what you'd have the case now if I said it is not the case that this or that, and this would be the negation of a disjunction. That could totally be a thing. Is that clear, everyone? Type in clear if that's clear. Ask a question if you have a question. Baby steps into this skill. And notice that parentheses matter a lot. Parentheses matter a lot. Like, this is a claim that's saying it's not the case that this or that. In English, what would this be? So I'm going to just delete all this. Imagine this is all now wrong underneath. But what would this mean here? What I'm going to put in purple. If you had to put this in English, what would the purple proposition mean? And you don't know what P stands for. Just say, use P and Q. It would not be the negation of a disjunction. What would this mean? It would mean what? What I've got in purple would mean either not P, right, or Q. Either not P or Q, or either, right, either P is false, right, either it is not the case, exactly, either it is not the case that P or Q, right? That's very, very different from what we had earlier. If I put the parentheses, that is not the same proposition. Now, we've said something dramatically different. So now this is actually saying either it's not the case that P or Q, which is very different from my saying it is not the case that when we had our parentheses around it. Let me just put back where we were. I've got the eye of Agamotto. If you know Dr. Strange, I can always do my undo. That's right. It's not the case that this. So you got to be really careful. These parentheses matter a lot. Now, notice what we're doing right now. This is the Russian dolls part, right? The atomic propositions, in this case, P and Q, are kind of like inside the conjunction, right? Because remember, this kind of swallowed up these other atomic propositions. And the conjunction, and you see it neatly with the parentheses, is kind of like inside the negation. So they're nested within one another as Russian dolls. The tiniest Russian dolls over here. Hello, my name is very small Russian doll. And then there's a slightly bigger, medium-sized Russian doll. Hello, I am bigger Russian doll. And I'm, and then you have the like really, really big Russian doll, that swallows everyone, right? That's all there. And that brings us to sort of this other idea that I want to sort of get you to wrap your mind around. And this is a fancy way. Russian dolls is a fancy metaphor for a relation called subsumption. So just so you know, or containment or subsumption, right? And it's an interesting logical relation that we're going to be playing around all month, right? But I feel like the Russian dolls really captures it. And if you haven't ever seen a Russian doll, they're really neat. Like I always was really satisfied when I would get to the tiniest one. And the tiniest, the better. Like the bigger the Russian doll, like if I was in Russia once, very briefly. If I ever go back and I could bring back like a lot of luggage, I want to get the biggest Russian doll you can imagine. So the larger the outside and the smaller the outside. Like I want to end up with like an Ant-Man sized tiny little Russian doll, a little lady inside. It's so satisfying. There's something about me. I don't know why. It's like it triggers all these good things in me. It's very satisfying to sort of put these Russian dolls into one another. And when you get to the tiniest one, it's as a kid, I had a cousin who had one. It was very fun. Is this subsumption relation clear, everyone? This Russian doll stuff? If that's clear, type in clear. If you've got a question, ask your question. It's a nice way to visualize what's going on logically. And our Russian dolls are going to be, actually, we're going to play with the analogy a little bit. They're going to be animals. I'm going to introduce you to the law of the jungle. Here's the law of the jungle in a nutshell. When an animal swallows another animal, you're left only with one animal, namely the outermost one. The animal in its belly is now food. I mean, the thing inside. So for instance, if I say, here, I'm showing you, let's say, a frog, right? and I say, what's Mark holding in his hands? Well, you'll answer a frog. You don't have X-ray vision, but chances are inside the frog is an insect of some sort. You don't answer, Mark is holding in his hands a frog and an insect, right? The law of the jungle says that the frog is essentially opaque. Whatever's in its belly doesn't count, right? So it's now food. What's in its belly is not like another animal. It's food. It used to be an animal, but sorry, it's slowly digesting in its stomach acids, right? And so the law of the jungle is this. When an animal swallows another animal, you're left only with one animal, namely the outermost one. So you wouldn't say there are two animals here. You'd say there are one. And you wouldn't say there's a beetle. You'd say there's a frog. That's the law of the jungle. Let me say that again. If you have a situation like the one depicted above, you wouldn't say there are two animals, you'd say there are one, and the animal you say there is a toad or frog, not a beetle. Is that clear, everyone? If the law of the jungle is clear, type in clear. If you've got a question, ask your question. And we're going to do a lot of mileage with it. Let me check base with you. Touch base. All right. Let's have some fun. Here's a lizard eating, here's a snake eating a lizard. Once the lizard is completely in its belly, and it's already dead because it's a constrictor, so it's or venomous. That's the two ways snakes make their living. Either it's probably venomous. It doesn't look like a constrictor to me, but either way, what are we looking at? Are we looking at a lizard or a snake? In virtue of our law of the jungle, yeah, it's a snake. It's a snake. And you know, the food chain being what it is. The snake has the unfortunate, precarious situation of being swallowed up by an alligator. What animal are we looking at right now? Yeah, crocodile, alligator. I'm not sure I can tell the difference, but certainly not a snake, right? So there's one animal, and it's the outermost one, which is the crocodile. And if you go on YouTube, there's really, really cool videos. Well, not a lot, but rare instances. And I think that tigers even do this for fun. Hypothetically, if the tiger swallowed up the alligator, what animal would we be looking at? It'd be one animal, and it would be the outermost one, which would be the tiger, because it swallowed up the. And it ends at some point. Food chains end at some point. In our jungle, there's no limit. But we do have a really easy zoology. So welcome to logic. In logic, there's only 6 animals in our jungle. Here are the 6 animals. There are atomic propositions. They're the bottom feeders. They're the tiniest little ones. There's negations, conjunctions, disjunctions, conditionals, and equivalences. So 1, 2, 3, 4, 5, 6. You're all biologists. It was the easiest biology class you've ever taken. You're all zoologists. Done. There's only 6 animals. It's going to be the stupidest, easiest thing in the world. And 6 is a nice number because, hey, it happens also to fall within our 7 plus or minus 2 range. It's not that complicated. Nothing is scary. There's only 6 animals in our jungle. And, you know, this is neat because they're both animals and Russian dolls. So I really love this particular picture. You can have a situation where the tiniest one looks like a little otter. I think it's so cute. All right, so let's play a game of what animal is this. So there's only 6 animals in our zoology. Let's name them again. Atomic propositions and all the ones named after the connectives we know and love. What animal is this? You're a zoologist now. Help me out. What animal is this? Taxonomize this. Tell me what animal this is. What's an atomic proposition? Exactly. And it's walking around in the forest, and it met up with something else. What animal is this? It got eaten. That's a negation. Yeah, the negation just ate the tiny little atomic proposition, was walking around just fine. You can imagine this would be needless parentheses, but what's in its belly? An atomic proposition, right? There you go. It just got eaten. And, well, you know, its belly is full. It kept its guard down. It wasn't paying attention. It got swallowed up. What animal is this? Only one animal. What is it? It's a conjunction. That's right. This is what that animal is. It's a conjunction. And it's a wild jungle. At any given time, you never know what's going to happen. And out comes yet another one. What animal is this? Hey, win some, lose some. Score one for the negation team, right? It's a negation. Um, and again, like I said, it's just completely crazy out there. Stuff's happening. What animal is this? It's a conditional. You got a code. It's a conditional. It's one thing. It's only one thing. It's only one thing. All right. What animal is this? It's a conditional. The whole thing. The whole string. Yeah. So Cole, can you see that? The whole string. Yeah. It's a conditional. Yeah. Um, oh my God. It's just completely wild out there. You never know what the hell's happening at any given time. It's just completely nuts. It's just like, oh my God, so much happening. But not to worry. This is one animal. What animal is this? Equivalence. Equivalence. What animal is this? It's an equivalence. It's not a negation. What's the negation sign ranging over, Michael and others? Does this negate? What does this negate? What does it negate? Small enough that you can tell me in the chat. It's negating something. What's it ranging over? It's negating D and J. That's right. It's negating this. That's what it's negating. So it's not the content of these brackets, namely D and J. That's right. It's not negating this whole thing. But what happens if I do this? I'm going to have to put my mustaches, because remember, we have a kind of a convention for parentheses. So this is my mustache bracket. So I always get a bit of a thrill when I use them. What animal is this? Now it's a negation. That's right. Now it's a negation. What animal is this? The whole string. What animal is it? Cool. You got it. What animal is this? It's a conjunction. It's a conjunction. So the law of the jungle, isn't that cool? Like, no matter how freaky looking something gets, at any given time, it's one and only one thing among six possibilities. It's either an atomic proposition, negation, conjunction, disjunction, conditional, or equivalence. No matter how complicated or freaky looking, now you're a zoologist, you're able at a glance to say, it's that. Is that clear and cool, everyone? If that's clear and cool, type in clear and cool. If you got a question, ask a question. We're taking step by step, and I'm going to make you succeed. This is how we succeed, because we put it memorably in our minds. And now we played the game of what animal is this. But you know what? We can also have some fun. We can also play a game of got the beast to see what's inside. All right, folks, let's start off. What animal is this? Correct. It is a conjunction. It's a conjunction. Let's now take a knife, sharpen that knife, and we're going to see what's inside. Right? Because we saw earlier, imagine if you were to gut the tiger, and inside the tiger you find the remains of a crocodile, and then you gut the crocodile, and inside you find the remains of a snake, and then you gut the snake, and inside you find the remain of some lizard, and then you got the lizard, and inside you find the remains of an insect, and so on. That'd be quite the thing. So let's do that. Let's sharpen our knife. Let's have a look. We know this is a conjunction. It's only one animal, and we're going to take our knife and we're going to cut it. What do we find inside its belly? Found a negation inside its belly. So we took our knife. It's still pretty sharp, right? And let me pause. Was that clear for everyone? Because if you're lost, type in lost. If you're clear, if it's clear, type in clear. Because I can't infer anything from silence. I want to make sure everyone's following along. If you're lost, and you're like, Professor, I don't know what the hell we're doing. Just write lost. If you're clear, write clear. And if you're like not writing anything, I can't tell anything because I'm scrolling down who I've got, and I need to hear from people because I love all of you, not just like a couple people who are more vocal. Like I love all of you, and I want to make sure we all kick some serious butt. Cool. A little lost out. Okay. So let's backtrack, right? What we had here, if you will, as the main connective, right? Ultimately, this was a conjunction, and it has at its right-hand conjunct P, and its left-hand conjunct was this whole thing. So you can imagine a conjunction is always a two-place relation. Well, what is it connecting? Well, on the left, it's connecting all this, and on the right, it's connecting all this. And so what we did was we said, okay, fair enough. Suppose now we trim the conjunction such that we end up only with its left-hand conjunct. Well, what was its left-hand conjunct? Well, we said that negation is a one-place relation. It's negating all of this, right? And so the animal that we have in front of us right now is a conjunction. A negation. What does it negate? All of this, right? And suppose we take this a step further and we sharpen our knife again and we gut it. What are we left with, Edric and everybody else? What are we left with? What's inside the belly? And you have to kind of just zoom out a bit and look. It's a conditional. It's a conditional. It's a conditional. You got it, right? Edric, does that help? Can you see that a bit? And the conditional is a two-place relation. So I'll have this on one side as its antecedent, and this on the other side as its consequent. And we can have something cool. All right, now let's trim its consequent, because remember that's what this is called, the consequent. Let's have some fun and trim its consequent. What are we looking at? And I've got some parentheses to trim, some extra belly skin to skin. All right, what are we looking at? What's this whole thing? Disjunction. We opened up its belly, and the disjunction had swallowed two disjuncts, right? And we're going to now take one of the animals that it swallowed and have a look at it. What animal is this? It's a negation. It's a negation. Avni, can you see that? Yeah. We take our knife, we trim. What are we looking at now, Avni? Now it's an equivalence. We're getting down to the little tiny beetle, the smallest little baby Russian doll. What is this? Our bottom feeders. Everyone eats insects, man. I hate to break it to you, but it all bottoms down to that. And insects eat poop. The next time you hear someone say the world is full of shit, it's probably true. Like everyone eats insects and insects eat poop. So just so you know, when you come down to your core essence, right, as an omnivore, well, plants eat light, but like you catch my drift. Certainly in the animal kingdom, right? That's how it works. And so there you go. Right? If we backtrack, we can have some fun. Again, I'm going to use my Eye of Agamotto undo button. And notice I could have had some fun when I was at the stage, for instance. Right? Let's trim this over here. What animal is this? Just to have fun, we could have looked at the other animals' bellies. Additional. And let's trim this. What are we left with? An atomic little proposition, the smallest little thing in our universe. And of course, an atomic proposition has no belly. There's no place to put it in, right? It's atomic. It can't be cut any further. My friends, is that clear and helpful? If that's clear and helpful, type in clear and helpful. If you're confused, say confused. We're doing good. All this is going to be paying off this month. And hopefully it's fun. It's not scary, right? Because, like, who wants to be scared? CNH, conjunction of both clarity and helpfulness. Nerd. All right. We're doing terrific. I'm going to close this. No, I do not want to save this. There we go. Stop sharing this stuff. Well, we did what we wanted to do, at least at this point. We did the Russian dolls. Now we know what the hell we're talking about. We did the easy zoology. How many animals are in our animal kingdom? Just to repeat. 6. Right, it's easy. 6. And you can kind of see them at a glance with a bit of training. It's like, wow, that's terrific. And the law of the jungle, which says there's at any given time only one animal, namely the outermost one, and it's opaque. Right? It's opaque. You don't see through its belly all of the things it swallowed, so you don't have to freak. Like, even if you have an animal that ended up eating like all sorts of stuff. So here's an elephant, right? It's the elephant in Surrey. Remember the good old elephant in Surrey? And it swallowed up a horse, and the horse swallowed up 2 dogs, and the dog swallowed up like at least 1 cat and a couple of mice and so on. Like, you don't have to worry about any of that stuff because you know what? You're at any given time dealing only with one animal, and in this case it would be the big elephant, and it'll be opaque. You don't look inside its belly contents. So the law of the jungle is terrific because it lets you not freak and take everything stepwise. All right, now we're going to work on being plumbers. So we're going to check for leaks. Now here's where we're going to apply all of this stuff. I'm going to open up another Word file. I'm going to share screen that with you. We're doing great for time, and we're going to leave ourselves time to practice and do all sorts of stuff. All right, let's do this. Here we go. Can everyone see this Tom and Jerry argument? If you can see that, type in yes. Good. All right. Take 2 minutes, symbolize this. I put myself on mute. 2 minutes, symbolize this. All right, paste what you came up with. Wunderbar! Terrific! I'm loving it because that's month 1, right? Look, everyone's able to do that. We couldn't have done that on the very first time we met. And look at our chat right now. Like, everyone's on the right answer. Even the spacing's really nice and sweet, you know. Terrific, right? That's the correct answer. Survey says, let's have a look at our answer. Here you go, right? Michael, you're missing some parentheses. Yeah. So where we have it, right? If Tom and Jerry get on the boat, so the antecedent is the conjunction, right? Tom and Jerry have to get on the boat and so on. We're going to get rid of human language to this month, right? But this is not a complicated argument. You could have figured out the conclusion on your own. Like if I would have said therefore ... you could have come up with the conclusion on your own. But even if this falls within the range of what we can fathom, right? And we had P and Q, Gusharanjit, so you want to stick to the scheme of abbreviation, right? So you can't just make up stuff. So that's going to be crucial. Even if we can figure out the conclusion, we still have the problem of how do we prove it, right? Suppose I say, well, you say the boat will sink. And I say, well, prove it, right? And this isn't, you understand, this isn't about boats, right? No knowledge of boat sinking is required for you to draw this conclusion. Does everyone see that? Because I could easily switch that over to something else. If that's clear, type in clear. You don't need to know anything about boats and water and whatever. If you see that, type in clear. Like, this is not about well, I once saw a boat and two guys went on it, and there's no worldly knowledge is required to get this conclusion, right? This is just, it follows from the premises purely logically, and that could just replace all of these things with different propositions for you to see that, right? And you could still infer the conclusion. And we have a problem now. It's like, even if this is easy, we still need to prove it. And so this is where the tools that we're learning are going to come. You know, all of this stuff, right? So we're going to build a truth table underneath. And we got a first order of business to figure out how many columns and rows are we going to use. Now, just a reminder, rows are what's horizontal and columns are what is vertical. And that's all what a table is, right? It's a combination of vertical and horizontal lines. And so well, we can take a hint from, let's say, basic connectives that we've been practicing. So here's a connective, right? And the connective has two atomic propositions. So P and Q, those are two atomic propositions. And when we cataloged exhaustively all of their possible truth value combinations, we ended up with 4 rows. It could be the case that P is true and Q is true. It could be that P is true and Q is false. It could be that P is false, Q is true. And it could be that both end up having to be false. And you can plug in different connectives for this. It really wouldn't matter. The moment you had a situation where you had two atomic propositions, we ended up cataloging 4 instances. And this was true of all of the drills that you practice. These columns were always the same. One of the reasons why it's not that difficult for you to commit to memory the truth tables is because, once again, there's so many constants. Those columns that were sandwiching, the buns, if you will, of the burger was always constant. And the only thing that was different was the patty inside the burger, right? So if we have 2 atomic propositions, we end up with 4 possible worlds out there, right? We don't know which world we're in. We don't know. We don't care because we're concerned only with logic. When we get to a situation where, let's say, go back here, right? We had 3 atomic proposition. P, Tom gets on the boat. Q, Jerry gets on the boat. R, the boat sinks. I notice because we're moving to symbolizations that let go of language, I really don't care to say T and J and so on. I can start P, Q, and R because really those are the conventions of the trade. So if you look at logic textbooks, P, Q, and R, for reasons that go back and are purely historical, right? Those are the letters we tend to favor. And so when we get to a situation where we have 3 atomic propositions like P, Q, and R, right? That's going to mean that there are 8 possibilities in the world. So irrespective of what P, Q, and R stand for, you could find yourself in a world where P is true, Q is true, and R is true. What's another possibility? Let's say at the other extreme, probably the easiest one to sort of wrap our minds around. So this is one possibility. The world might look like this. It could be that, could be that everything you said is true. Maybe. Another possibility, like she says, true, true, and false. That's right. Right? That could be one. What would be this one? So let's go at this one. Kamal, you got it, right? Let's go. This one be that no-brainer one as well. Let's at the opposite extreme. They could all be true and they could all be false, right? It's like everything you said is false, bro. I get what you mean, but it's like, no, it's all false, right? You said, for instance, that Tom gets on the boat. Well, guess what? I checked and he didn't get on the boat. You said that Jerry gets on the boat. Well, guess what? I checked and he didn't get on the boat. And you said the boat sinks. Well, guess what? I checked and the boat doesn't sink. So you could totally have this possibility, right? Another possibility you can imagine, and there's quite a few here, right? Folks are sort of, Ram's got F, T, T, right? T, T, right? You could have a situation like this, right? You can have all sorts of situations. So you're going to end up with a bunch of these possibilities. And one no-brainer way of figuring out how to fill in all of these possibilities, because that's your first order of business. You can imagine if I were to really empty this out completely, and I say fill this up completely, and I say, for instance, I had a conditional, right? Well, your first order of business would be to say true, true, false, false. It's kind of a nice mechanical way of filling it up. True, false, true, false. And then you'd fill up the harder to think about ones. And the way you'd fill them up, and note this, you'd look at the 2 things that are being related and figure out the total truth value for them. It'd be like true, right? So you'd say this like this. Let me put all this in black. black and bold. Here we go, right? So if true, then false is what? And that's when you really get to say that someone didn't keep their promise or the prediction didn't bear out, right? The things that they said were the conditions that had to be met were met, and the outcome wasn't the outcome. So that's when you can declare that what they said was false. In any other circumstance, it ends up being as true. It's like we learned this lots of weeks ago. But notice the first step here was very mechanical. We kind of had to think about relating these things, and that's where you had to drill yourself in the first month. But this is fairly mechanical. True, true, false, false, true, false, true, false. Well, one way of figuring this stuff out, instead of sort of, and it's not only is it quick, but it's going to put us all in the same pages as follows, because we have all these different possibilities. We want to go from this possibility to this possibility, right? And every possible combination in between, which is going to mean 8 possibilities in this case. So what we do is we're going to do this. For the first column, if you have 8 rows, go 2 by 2. So you imagine all of these are going to end up being true. Okay? So true, true, caps lock here, true. And then false, 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 false. So it's 8. So you go 4 by 4, right? So true, 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 false, 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 right? And then you're going to double up the tempo. That's right. So you double up the tempo. This was 4 by 4. So just like if you were drumming, now you're going to double up the tempo. You speed up the tempo. You're going to say true, true, false, false, true, true, false, false. And then you, again, speed up the tempo a little more. True, false, true, false, true, false, true, false. If you do it this way, what I call quilting, because it looks like a quilt. You know when you're quilting or crocheting? Does everyone know what crocheting is? My partner likes to crochet. It seems to be a thing, especially with the pandemic. Crocheting or quilting, stitching, knitting, I don't know. All these things mean something. If that means something to you, say yes. If you've never heard of such a thing. When you make damn clothes, like you make a toque or something, a scarf. Yeah, just like it's this repetitive thing, crocheting, right? Yeah, like it's a thing, right? And so what we want to be able to do is we want to be able to quilt all these truth values in fairly mechanically. And the dumbest way to do it is to go so double up the tempo each time. So you can imagine, right? Look at the tempo here, right? I'm going to just put colors just so we can see. There's no point to these colors other than just to show you sort of the pattern. Just like when we're crocheting, there has to be a pattern, right? Notice the pattern here. So we're doubling up the tempo. Doubling up the tempo. I'm going to call that quilting. And it's the good news is that's one of the more mechanical parts of this skill that you're learning this month, right? So you take the first row that you encounter, top half all true, bottom half all false. And then the other one's going to be half of that. So half of that, and then half of that. So this was 4, 2 by 2, 1 by 1. So 4 by 4, 2 by 2, 1 by 1. And then what that does is it guarantees that we've covered all possibilities. True, 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 false, true, false, true, true, false, true, false, true, true, false, true, false, 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 true, and then false, false, false. There's no connectives yet, right? These aren't connectives. These are just atomic propositions, right? But we want to be able to at least catalog all the way the worlds might be. Is that clear, everyone? If that's clear, type in clear. If you've got a question, ask your question. That's just one sort of step in the method. Pretty mechanical one. I don't know what world we happen to be in. I don't even know who these people are. Who the hell is Tom? Who the hell is Jerry? And where's this boat? Right? Who knows? Who cares? It's the beauty of being a logician. You don't need to actually figure stuff out. You figure some stuff out, just not that. We're concerned, if you recall, with coherence, not correspondence. So we don't know which world we're in. So once you've done that, what you can do is you can have an argument like the Tom and Jerry argument. We let go of the language. Now this is, I think, the final goodbye to language. Bye-bye language. We only care about this now. We've transformed it into symbols. We know what these symbols stand for. And this would be the template you get on our empty word template. So everyone go to the top of our course and have a look at Course Essentials. You've looked at it for your shortcut keys. Can everyone confirm that they can have access to what's called the template and shortcut keys? It should be a Word file. If you can open that up, type in yes. It's very important because you'll need that for your homework. If you can't get that, you can't do your homework. You've seen this already because that's where the instructions were for the shortcut keys, which are terrific. You still need to keep your shortcut keys. We'll be using them throughout the entire semester. They'll be your best friend, trust me. And so in it, you have all of these different tables, right? Now, if you keep scrolling down, you'll see a truth table with 4 rows. There's a truth table with 8 rows. What's the one after 8? If you keep scrolling down, there's another an empty truth table. How many rows does that one have? 16. And then after that, what's the next one? How many rows does the next one have? 32. Is there one beyond that? I'm not looking at it right now, and I forgot how many I gave you. 64? Cool. What do you think would come after 64? So look at the chat right now. 8, 16, 32, 64. What would be the next number in the series? 128. Yeah. So these things get multiplied like fairly rapidly. Like, for instance, here we have 3 atomic propositions. When you have 3 atomic propositions, you end up with 8 possible combinations, right? There's 8 ways the world might be. If you have 4 atomic propositions, there will be 16 ways the world might be. So instead of having only 8 rows, you'd have 16 rows, which is not the end of the world. You would still fill it out the same manner, half by half, and then double up the tempo. So half by half, and you double up the tempo. If you have, so at 4, you'd have 16 possibilities, right? And so the idea is, look at your hand, for instance. Put your hand in front of you right now. Look at your fingers and look at your thumb. If you just grab your thumb, so do exactly what I'm saying. So I really want this to be intuitive. Look at your fingers right now. Open up your hand, have a look, palm facing towards you. Grab your thumb. If you grab your thumb and that's only 1 atomic proposition, there's going to be only 2 possible truth values. What you just said is either true or false. So if I say, Mark is 9 feet tall, well, that's just grabbing your thumb. I just made an atomic proposition. This could either be true, it could be false, right? So far, so clear, everyone? Type in clear. You're grabbing your thumb. That's just 1 atomic proposition. There's going to be 2 truth values. Then you're going to point to your index finger. Suppose you have 2 atomic propositions. So you're counting your fingers like you learned in childhood. 1, 2. There's 2 atomic propositions. I said, Mark is 9 feet tall and he's a professor. I made 2 claims. So there's 4 possibilities. It could be a 9 feet tall professor, someone who's not 9 feet tall and he's not a professor, someone who he is a professor, but he's not 9 feet tall, or I am 9 feet tall and I'm not a professor. So 2 atomic propositions means 4 truth values. That's the drills you've been practicing. If you count 3 fingers, so it's 2 times 2 makes 4, times 2 makes 8. So by the time you get to your 3rd finger, that's the middle finger, right? You'd have 8 rows. Times 2, 8 times 2 makes what? When you get to your 4th finger, 16. Times 2 makes what? So if you have 5 propositions, you're at your little pinky, little finger. You're at how many times? So 16 times 2. Each time you double up. And if you keep going and you have to open up your other hand, you go, and so now it's times 2. So we have 6 propositions because now you have a full open hand. 1, 2, 3, 4, 5, plus another finger. So times 2. 64, and you keep doubling like this, right? So mechanically what you do is you count the number of propositions that your argument has, and then you're going to figure out how many rows it's going to require. And don't worry, as big as they get, they won't be scary. I'm always going to keep everything down to 3, right? We're going to break it down into bite-sized pieces, but right now let's just practice on an argument that has 3 atomic propositions, and thus there are 8 possibilities that it paints out in the world, namely those cataloged here. So far, so good, everyone. If that's clear, type in clear. If you got a question, ask a question. It just goes to show this could expand. The method can exponentially expand. It's really no problem. It's like a uterus. My partner always likes to tell me when she's pregnant, like the uterus expands like 1 billion times or whatever's the number. It's a really fascinating thing. Well, think of that as well. All right, so here's our argument. You've got your template. You know where you got this. You got this in that damn Word file. And this would be like the question you would have, let's say, in the homework. And I believe I put them all at size 13 because that's the convention we've agreed. What you're going to do is you're going to copy paste the question from today's homework that you're going to practice this week, and you're going to put it in that top row. Notice the top row here. I've got dividing lines. This is for separating premises, and I've got a double slash. This is going to be for separating the conclusion, right? And I know it's a little small right now, but I'm sure everyone can see decently. And I'm going to go ahead here and copy, paste, and report back each particular slice. Not the parentheses; they're slightly different. They behave differently. Oopsie, I need my close the parentheses and Q over here, right? And I'm going to report back all of this argument inside my grid so that I can play along and build my truth table. So for instance, now I've taken all of this and I've put it over here, and then I've got my single slash already here, and that's terrific. Now, what am I going to put over here? What should I be putting in this space over here? Given the argument that I'm trying to figure out. Yeah, P, and remember it's a capital P, so I'm just going to go copy. I'm going to put this here. What should I be putting over here? Ignoring everybody else. A divider. So you're going to put a single slash. And notice for visual, and this will really pay off in the long run, I'm going to select all of these over here. So not only am I going to give myself my single slash, I select all these things, and I'm going to go right click. Can everyone see the little window come up when I do right click? Or is that just for me? Can you see that little thing? Cool, everyone can see that. And I go over at borders and shading. There's borders, page border, shading. And I'm going to go for shading, and I'm going to say shade. I believe I said 25%, I think. Shade 25. Let's see if I got it right. Yeah, 25. So shade that 25%. That's a nice visual cut. And we want to give ourselves as much as possible the visuals. Oh, still on caps lock. All right, here we go. The visuals to be able to really discern these separators. What am I going to put over here? Given the argument I'm trying to figure out. Exactly. And what am I going to put over here for my conclusion? R. Cool. Once you've done that, that's one step of the homework. I want you to, don't skip the following step. I want you to double check everything you did. Because if you screw up, because it can happen in pasting these, copy paste, because I'm giving you a standard template. Notice how I had to modify the template to add a separator here, right? The original template didn't have one. I had to add it. You're going to have to modify these things. You could be making a mistake. It could easily happen. Why would you be making a mistake? Because you're that dumb monkey we started with, right? And so am I. So please double check before you start working on your truth table. Make sure you actually got this right, because otherwise you'll work really hard and it'll all amount to absolutely nothing because you didn't copy paste it properly. Is that advice clear, everyone? If that's clear, type in clear. If you got a question, ask your question. Because Sensei Mark loves you. Like, I would hate for you to spend a lot of time working on something and damn, this wasn't even the right argument. You pull out your hair, right? It's like the hair will fall on its own eventually when you get older. Don't let it fall right away. All right, so now we verified. And someone spot me. Did I make any mistakes or is everything fine? Type in fine if I'm fine. Because maybe I make mistakes as well because I'm like you. I'm a dumb monkey. I think we got it right, right? If P and Q, then R. Second premise P, third premise Q. Okay, cool. All right. Now what we're going to do is we're going to fill in our truth values, and we're going to fill in our truth values for our atomic propositions. So notice our little insects here. These are our atomic propositions. How many atomic propositions do we have in this argument? How many letters? How many uppercase letters do we have? We have P, Q, R. Well, types, not tokens. We have 3 atomic letters. Well, there's a distinction there. It's true. There's a sense in which we have 1, 2, 3, 4, 5 token letters, but we want, like, there's 4 types. All right, so fair enough. So we have 3. So you take out 3 fingers. Do that now if you want. And you count 2 times 2 makes 4 times 2 makes 8. So we're going to have 8 rows. We've already got that because we grabbed the actual 8 row grid, but if we needed a 16-row grid, Papa Bear's made one for you. A 32-row grid, Papa Bear's made one for you. And you can make one on your own if you want to keep adding, but use the template because I want all that to look good. And in the test, I'll actually give you the grids most of the time partially made or fully made. All right. Let me pause and take baby steps. There are 3 atomic propositions, P, Q, and R, which earlier stood for this, but frankly, at this stage, we don't care anymore. P, Q, and R. Thus, we're going to have 8 rows. So far, so good. If everything's clear, type in clear. If you're lost, type in lost. Step by step. Learn this once, learn this well. Remember, if you're lost and you don't tell me, I'll never know. I'm not a mind reader. I wish I was Professor X. Holy cow. But I'm not. I don't know that I want to be Professor X, though. So on reflection, that's not that great. All right. So how are we going to do this? Well, that's where our quilting comes in. 4 by 4. So you divide in half. 8 divided by half makes 4. So what you do is, here I'm putting caps lock on, T, 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 F, 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 F. See how quick that was? T, 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 F, 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 F. 4 by 4. And then there's the beauty of copy paste. You grab this whole thing, you copy, and this is the truth value assignment you gave to P. Why did I start there? Just because. It's like eating corn on the cob. Start from left to right. First atomic proposition you meet, that's the first one you're going to do, right? So you just start there. There's nothing magical about P. Let me zoom in. There's nothing magical about the letter P that requires it to have these possible truth values beneath it. Nothing magical. This could have been D for all I know, right? It could have been whatever. It's just that it's the first one that showed up, and I'm going to go from left to right. Is that clear, everyone? If that's clear, type in clear. If you got a question, ask a question. I'm step by step. Follow this method. I worked at a fast food joint. Someone taught me how to do like French fries, and it's like, if you do it this way, you'll never cut your finger, right? But if you do it this other, if you do it whichever way, you're going to run into trouble because cutting up stuff with and hot oils and whatever, do it the right way. So Papa Bear's training you. Then you take copy. And look, that's the truth values that you assigned for P. So whatever world you're in, let's say you happen to find yourself in this world and P happens to be true. Well, if P is true in this world, then it stands to reason that it'll be true as well here. It's not like you can have a situation where, the first time you said P, it was true, like Mark is a professor, but then the second time you mentioned that he wasn't. Like if it's true in one world, it's still true in that world. It could be false. Maybe I'm not a professor, right? That's fair enough, man. Maybe I'm not a professor, right? And then you'd be false. But either way, if I am a professor, then I am. And if I ain't, then I ain't, right? So whatever is going to be the truth values are going to be the same. So what you want to do is you want to take this, right? And you want to paste in all of the same truth values that you had. In this case, 4 by 4. And you want to do that for every instance where that capital letter shows up. You started from left to right, but then you scan the argument and you look for any instance of P. Next instance, no, that's not P. That's not P. That's not P. This is just a slash. Oh, here's P. Paste it right in, right? Paste it right in. Is that clear, everyone? If that's clear, type in clear. If you got a question, ask a question. Next question. Who's seen the movie Whiplash? Type yes if you have, no if you haven't. You so need to see this. Michael, do you agree? Do people need to see this? Michael's the one person who said yes. Like, that's a really damn good movie. Okay, it's about a drummer, right? It's a drummer. Have a look. So Whiplash. It sounds like nothing. It looks like, well, who wants to see a movie about that? It's hilarious. And it's a drama. It's really serious. A drummer has to have good beat. Have to have a good tempo, right? So you're going to double up the tempo. Speed up the tempo. This was 4 by 4. So what are we going to do here? What's going to be the tempo for the next one that we encounter? As we do our corn on the cob, we'll get to the next part. It was 4 by 4, and I'm going to do what tempo? 2 by 2. 2 by 2. You got it. True, true, false, false. True, true, false, false. Exactly. Now we've done that for Q. Well, same thing. We got to do that for all the Q. That's not a Q. That's not a Q. That's not a Q. This is already done. It's not a Q. Neither is this. Neither. Oh, Q. There you go. Paste it right in. right? And then we finally speed up that tempo. This was 2 by 2. So what's the last one? You always end up with that tempo. True, false, true, false, true, false, true, false, true, false, true, false, true, false. And you go. There you go. Right? And that was for R. You go in and you paste that for R. This is all preparatory stuff, and it's really mechanical. And what we've done is we've cataloged 8 possible worlds in the same manner that we did here. 8 ways the world might be without actually checking, because we can't check. We're just logicians. We don't get paid enough for that, right? And there you go. These are 8 ways the world might be. We don't know which one we're in, but we've exhaustively cataloged all of the possible combinations. Like Doctor Strange at the Endgame battle, I've looked at all of the possible universes, and this is the only way we win. Is that clear, everyone? If that's clear, type in clear. If you got a question, ask your question. All right, so now this is where we're going to have some fun. Which should be the next column that we fill? Because we've got this here that's empty. We've got here that's empty. Here, there's nothing to say. We're not going to put anything in these shaded areas, right? Well, if suppose I wanted to figure this out, well, I'd have to figure out my animals here. What animal is this? Here's where we got to get clear on our zoology and our law of the jungle. What animal have I selected? It's a conditional. A conditional has an antecedent, this is its antecedent, and a consequent. Now we know the truth value of one of its consequent, but we don't know the truth value of its antecedent because we haven't figured this out, right? We haven't figured this out. We need to figure out this kind of stuff. So what we're going to do is we're going to figure out this row here, because once we figured out, this column here, only once we figured out this column underneath the conjunction will we be in a position to figure out the column underneath the conditional. Let me say that again slowly. Only once, let me zoom in, because we don't need to sort of focus on this other stuff. Let me zoom in solely on the first premise. Only once we figured out the truth values to put underneath the conjunction will we be in a position to figure out the truth values to put underneath the conditional. Is that clear, everyone? If that's clear, type in clear. If you have a question for why we're going to do that, ask your question. That's the law of the jungle. That's where all it pays off, right? We need to figure out the smaller one to build up to the larger one. The Russian dolls, right? Because how would you know, right? Like right now we know that this is true, but like how would you figure it out? So, okay, so let's figure this out. And at any given time, remember I said there's only 3 things you're going to keep in mind. Well, there's going to be 2 knowns and 1 unknown. Here's 2 knowns, 1 unknown. What should I put here? True and true is, this is where your drills. Wax on, wax off is about to pay off. True. True and true is? True. True and false is? False. You got it, Kelly. True and false? False. False and true? False. False and true? False and false? False. False and false? False. Wax on, wax off. Yes. Good stuff. Now we know this, right? Now we can kind of discard this. What got us there, I'm going to put it in gray. This is a little trick I use, right? It just helps me visually be much clearer. I'm just going to put these in a light gray so that they kind of are not, they're still there, right? But they're less sort of in my way because it gets visually, I don't know, it's a little cluttered, right? And now again, same thing. Well, at any given time, no more than 3 things in your mind. 2 knowns, 1 unknown. If true, then true is true. Exactly. Second row now. If true, then false. Notice what we're relating. True as an antecedent, false as the consequent. That is false. If I have a false antecedent and a true consequent, then the whole conditional is true. What about here? If false, then false. True. If false, then true. True. If false, then false. True. If false, then true. True. And if false and false, true. You got it. Now, same rationale. I've obtained this. This is the column that represents my animal. What what animal was premise one? Let's remind ourselves, our easy zoology. The first premise was a conditional. That's right. It was a conditional. And what did it eat when we opened up its belly? It ate two animals. It ate as an antecedent, yeah. It ate a conjunction, right? And it ate an atomic proposition on the right side as its consequent. We can get rid of this now. I'm going to put this in gray. We can also get rid of this, and I can put this in gray. I find the graying really helps. It's not like an official part of the method, but I feel like visually it really helps us figure it out. And here you have all of the ways in which this compound proposition could be in the world, right? This proposition could be true, false, true, right, and so on, depending on the possibilities cataloged with our atomic propositions. Then we move on to premise number two. Well, that's a no-brainer. It's an atomic proposition. That's already been figured out. Then we move on to the third premise. That's already been figured out, and we've got our conclusion figured out. So then you take a deep breath and you congratulate yourself because you've achieved a nice step in the method. You've filled up your entire truth table. What are we looking at, essentially? Well, what we're looking at is a situation where we've cataloged all of the way the world might be without actually checking which world we find ourselves in. And what we want to figure out is this a valid argument? And valid for us is a technical term. A valid argument is an argument where if the premises are all true, the conclusion has to be true as well. Like you can think of it as a form of plumbing. Like think of the premises as pipes that all lead to a conclusion. So you can imagine, for instance, here's a bunch of pipes, right? And if you were to pour in water, it would all, let's say, come down to a tap. Let's say they all sort of boil down to somewhere where you're going to wash your hands and so on, right? And so what you want to figure out is this a valid argument? And a valid argument is one where every time you pour in the water at the top, it comes out without loss at the bottom. Like think about it this way. You're about to buy a new house with your partner and you want to check the plumbing. Let's say the house has a ground level and a basement and you want to check the plumbing. What's a good way of making sure, let's say the salesperson assures you the plumbing is perfect, it's watertight, it has no leaks whatsoever. What would be a good way to test plumbing? Your partner and you want to test, you don't sort of take at face value what you've been told about the plumbing. You've been assured it's watertight. How could you check that? What would be a practical test you could do? You could turn the water on, right? That would be one way. And then what would you do if you turn the water on, Kelly? Then what? So you turn the water on. That's one step in your test, right? What else would you be doing while you do that? So there's water, that's great, but they told you more than that. You check for leaks. Exactly, you check for leaks. So here's a very sort of more scientific way of checking it. Like, imagine, for instance, like Samuel and I are going to buy a house, right? And we want to check, like, whether or not this has got perfect plumbing. I tell Samuel, I say, grab a liter of water, Samuel. Go upstairs and pour it in the sink. All right, pour a liter, and I measure it carefully, a liter. Right? And then I go downstairs where it's going to end up, let's say, and I put a bucket. If the water is indeed watertight, there are no leaks, how much liquid should I be receiving at the bottom? If Samuel pours a liter, how much should I be receiving at the bottom if the salesperson didn't lie? 1 liter, right? What happens if I receive like 0.99 liters? Is the water perfectly watertight? The plumbing perfectly watertight? No. We're looking for perfect plumbing here. Someone wasn't bragging that it has okay plumbing, that it has plumbing. It was saying perfect plumbing, right? Perfect plumbing is a situation where if you pour in the water, you get exactly what you put in at the top, right? With no loss. There's no leaks. Well, you can think of a valid argument as a form of perfect plumbing, right? If you plug in true premises, that is, if you pour in a liter of water here, and you pour in a liter of water here, and you pour in a liter of water here, what's your friend in the basement supposed to receive at the bottom in their bucket? So you poured in a liter in the first premise, you poured in a liter in the second premise, and you poured in a liter. What should they be receiving? 3 liters. And if they receive anything less than 3 liters, what can you conclude, Samuel? Imagine, is anything less than that, then is it perfect or less than perfect? Leaky pipes, is it perfect or less than perfect? Because perfection is pretty demanding, right? Like someone says it's perfect. That's pretty, yeah. Like how many flaws does it take to be less than perfect? How many flaws? I claim I'm perfect. Like one flaw and that's it, just one, right? That's why it's very careful. You got to be careful with claiming these things. A valid argument. This is our philosopher's word for perfection. It's like saying a perfect argument. And a perfect argument would be one where whenever the premises are true, the conclusion has to be true as well. So what we're going to do is we're going to check for leaks. So we're going to go over to our argument and we're going to check for leaks. Now, obviously, if Samuel hasn't poured the water in this premise here and the water in this premise, let's say Samuel hasn't poured water. He's poured water over here. Let's say he's poured water a liter here, but not in the liter in the first one. He didn't pour anything, right? It's normal that I wouldn't receive my 3 liters because he didn't pour it in, right? So we want to look for situations where, in fact, in all of the sinks in the kitchen, let's say this is the first sink, second sink, third sink, he poured the water in. So we're going to look for situations where the premise as a whole is true. Here's a world one, where that first premise is true. Here's a world in world one where the second premise is true and the third premise is true. How does the conclusion come out? Terrific. So far, no leaks, but we got to keep testing. Here's a situation where Samuel didn't pour any water into that sink. That's not going to be a row that interests us because he didn't pour water in there. So it doesn't matter what we end up with, right? It's not going to tell us much because we didn't actually test it for leaks. Here is a world where he pours the water in, pours the water of truth, didn't pour the water. Well, that's not going to be helpful for us because we're not testing all of these plumbings. Because remember, they kind of all combine together, right? In a way that's like this. So we all sort of want to check only the ones where all of the premises were true. This is true, false, not going to be a row that interests us. This is the first premise is true, second premise is false. So, that's not going to be a row that interests us. This is a row where first premise is true, second premise is false. I mean, this one's true, but this one's false, so it's not interesting. Here again, no. Here again, no. And then I step back and I remind myself the definition of a valid argument. A valid argument is one where if the premises are true, the conclusion has to be true as well. There was one circumstance in which all of the premises were true. How was the conclusion? It was true. So is this argument perfect? I get you to nod yes here. You said, yes, Mark, I agree. I get you to nod yes here. Yes, Mark, I agree. I get you to nod yes, Mark, I agree. So you've agreed, in this case, what was it, right? You've agreed that Jerry gets on, that this was true. Like if you've agreed to this entire premise, right? That if Tom and Jerry get on the boat, then the boat will sink. And you go, yes, you've agreed. Nodded yes. And you've agreed that Tom gets on the boat. And you go, yes, he does get on the boat. And you've agreed that Jerry gets on the boat. And you go, yes, he gets on the boat. I don't know why you were more excited about Tom or Jerry than Jerry, but who cares, right? And then you go, the boat will sink, right? And you go, no. Like if you did that, you'd be logically inconsistent. If you've agreed to the first premise and you said yes and you nodded yes, and if you agreed to the second premise and you nodded yes, and you also said yes to the third premise, then you have to say yes to the conclusion. Otherwise, you're what we call a fool. You're inconsistent, you're illogical. So you have to say yes as well to the conclusion. And that means that the argument is, drum roll please, da-da-da-dum. What's the technical word for an argument where once you say yes to all the premises, you have to say yes to the conclusion? The technical term is a valid argument, which is our way of saying it's perfect. It's perfect plumbing, right? In those circumstances where you plug in the water, right, the water comes out perfectly at the other end. And this is how we're going to test for leaks. Are there any leaks? Let me just undo all this stuff and get back to my previous thing here. Boop, 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 boop. There are no leaks in here. A leak would consist in having true premises and a false conclusion, and we have none of that. And then we can say this is the net value of our method, that the argument is a valid one. My friends, is this clear? If this is clear, type in clear. If you've got a question, ask your question. is perfect plumbing. It is verifiably ISO 2902 certified perfect plumbing logical argument. I get you to agree to those premises. You have to agree to the conclusion. You're compelled by logic to say, yeah, because I'm just rearranging the things you've agreed to. Cool, right? It's like, think about it. This is what Socrates used to do, right? This is what we philosophers do. I listen to you talk, and I only will use the materials you've already committed to, and then I will rearrange them in a way that I surprise you with the conclusion, and I have you to you have to agree now, because that's literally what you yourself said, right? Samuel says, is the goal to find a valid argument in the table or just to fill out the table fully? The net product is to declare it either valid or invalid and to have the paper trail to back that assessment up. There's only two possibilities. It's either valid or invalid, right? So either it's going to be valid with a V or invalid with an IN, and you want the paper trail to back up that judgment. Samuel, is that clear? We're going to practice some more. Yep, that's the goal. That's the end value. That's the sort of the net practical value of everything we're doing this month. Yeah, I see. So valid is all true premises with a true conclusion. Yeah, if the premises are true. Sometimes you can have a situation where none of the premises are true, whatever, but in whatever, they don't have to be true. So this is where, let me just kind of pause for a second, right? Let me make a distinction here, right? Remember we were concerned with this. Does everyone remember this? Type in yes if you remember this. We saw this in, I want to say week 1. So 3-4 weeks ago. Cool. What are we concerned with in this class? Coherence or correspondence? Which of these two axes are we concerned with? The axis of coherence or the axis of correspondence? Coherence. Yeah. Like we don't care about correspondence one bit, Samuel. We only care about coherence, right? And so what we care about is just this. We want to tidy up the relations between those units of knowledge, which we now know are propositions, right? Yeah, and we don't care about this. Now this makes for, and this is a sort of long-winded and nice kind of answer to your terrific question. This makes for a division of labor, Samuel and everybody else, right? The scientist checks for correspondence. The scientist is going to figure out which world we're in. The scientist is in a position to tell you whether you're in world 1, world 2, world 3, or world 4. And they're going to come back from their empirical investigations. They're going to have to put on their boots, right? And they're going to have to get their hands wet, and they're going to come back and say, this is the world we live in, right? So for instance, if I say, for instance, this would be a conditional, right? If you smoke, then you have cancer. Yes, that's true. And you smoke. No, actually, I don't smoke, right? And so if I say, for instance, that you have cancer, yes, you'd still have cancer. You could totally find yourself in that world. It's true that if you smoke, you have cancer, right? You don't smoke and you have cancer. Let's say you had, skin cancer or whatever for other reasons. And the scientist says, you live in this world. And you need empirical knowledge for that. I can't tell you which world you live in. Right? I can't tell whether it's true just by looking that if you smoke, then you have cancer. Staring more at this proposition is not going to make me figure out whether it's true. Could be true, could be false. I can't tell whether you smoke just by looking at this. I can't tell whether it's P or true, right? And I can't tell whether the conclusion is true or false. And all of these things are empirical matters of fact that need to be investigated with measuring instruments and all that. Yeah. But we don't care about this stuff because that's the scientist's job. And the scientist cares about correspondence. That is, the science wants to figure out truth. We want to figure out another property called validity. And we logicians, we only check for coherence. So all we're concerned with in an argument like this is, does it have leaks? That is there ever a circumstance where all the premises are true, yet the conclusion is false? Well, let's check. True premise, true conclusion. You poured 1 liter, 2 liters came out. You didn't pour anything. That's not a row that interests us. You didn't pour, you poured something here, but you didn't pour anything here. That's not a row that interests us. And here's a situation where one sink you poured water, the other, well, okay, cool. There's no situation where when you have true premises, the conclusion is false. In all instances, whenever you accept the premises, you have to accept the conclusion. And which world are we in? I don't know. Right? That would be something called soundness, which would be validity plus truth. If you happen to be in a valid argument and all the premises are true, it's like having a grand slam as opposed to a home run. All bases were loaded and you hit the home run. That's called a grand slam. The technical term for that is soundness. But we're only concerned with that. So that's a division of labor. Samuel and everybody else, is that clear? That's a great question. If that's clear, type in clear. If you've got a question, ask your question. We're only concerned with this. Tidy that stuff up. I got you to say yes. Like, I don't know at all. Like, if you say something like, you said yes to this claim, and then you said yes to this claim, and then, well, I rearrange them, you have to say yes as well, because they're logically rearranged, right? There you go. I think that's a really cool thing, by the way. I didn't know that was a thing. So when I was young, so here's a brief anecdote, right? When I was young, I used to think that if you wanted to be smart, you had to be a scientist. So I didn't know about this. And I thought, well, I hate science, therefore maybe I don't want to be smart. But I didn't know that there was this possibility that you could do this, right? And when I discovered that this was a thing, I went crazy. I'm like, this is so cool, right? Ignore writes, do we consider a false in a premise a leak or false? Well, we're going to practice that. Ignore. Put that on the shelf. Ignore, you just got a message. Man, check your phone. Ignore, is that good? Put that on the shelf. It's going to fall into place. We're just taking baby steps. Yeah. Cool. Here's your text message. Someone texted you. The managers are not planning to give themselves a raise. I know this because if managers plan to give themselves a raise, then they will either raise the pay of the analysts or ask for more money from the investors. The managers have indeed asked for more money from the investors, so that proves what I said, right? This person's giving you an argument, right? The conclusion of their argument is this, not M. The managers are not planning to give themselves a raise. Notice that's the first sentence they said. That ends up being their conclusion. And at the end they say, so that proves what I said. They claim that the reasons that they gave, proves this, that the managers aren't planning to give themselves a raise. All right, well, let's figure that out. First order of business, and we don't really care about language anymore, so I'm just going to put this in shaded over here. What is this? Don't know, don't care. But that is a good symbolization. I'm assuming you know how to do this. We want to copy paste this to the top. I'm going to copy paste this, right? Copy paste this. I call this staking. When you're going to build these grids, does anyone know the difference between a steak and a fillet? Like if you're into meat, like fish, steak and fillet, what's the difference? Call this staking, fishing. No, steak and fillet, that's not the difference. Let me teach you something. So a steak is when you cut the meat against the grain. You know, like muscle fibers, like imagine your bicep, right? The muscle fibers run from like your shoulder to your elbow and they run lengthwise. If you cut the meat against the grain, so against the direction of the fibers, that's called a steak. If you run your knife along the fibers, that's called a fillet. So think about a fillet of fish versus like a salmon fillet versus a salmon steak. Right? Like it's kind of, or a T-bone. T-bone is a steak. Like you need a saw and you go against the grain of the meat, right? Red meat tends to be pretty tough, so you want to kind of cut it against the grain. You can think of the roes, when you sort of make the roes, that's filleting. You go with the grain, and you can think of what I'm doing right now as steak. Like here's a T-bone, like, and I'm kind of carving this now. I'm staking it. Like I'm taking kind of like a T-bone, right? I'm cutting this up. Right? I'm staking it. Did you like that distinction between steak and fillet? Next time you go to the supermarket, have a look in the meat section. Steak and fillet. Does that make sense? You just learned something. It's not logic, but you learned something. Steak and fillet. I happen to love my fish as a fillet. I hate it as a steak. Like you give me salmon steak, I hate it because there's like bones and stuff. When you fillet it, you can fillet across with like and get all the bones out. But I want the red meat to be, we rarely eat red meat as a fillet because it's too tough. So I'm staking it, passing a saw through it. I'm sawing this argument. And notice you have to saw well, because you can saw poorly. If I did this, I'd be sawing poorly. Why would I be sawing poorly? Suppose I didn't stake correctly. You suck, man. Don't you butcher. You can't cut a steak worth a damn. Why? This would be incorrect. You'd be confused. Your homework would be all confused. You're going to mess up. And you get 0. Why am I not staking this correctly? Yeah, it should stay within the bracket, and they don't have a truth value. Exactly, that's why. So what Anna said is right, and what Samuel says is why it's right. Right? It doesn't have a truth value. Like, what in the world would I put here? Like, think about that. Like, then I'm filling this up. What is that? Like, parentheses is not a connective, right? So let me use my undo. Can everyone see why this would be clear? This would be correct, and just putting the parentheses wouldn't be? If that's clear, type in clear. Like, you just take that stuff right. That's a skill. Like, I'm doing it fast, but I just want to make sure that that's why my digression about steaks and fillets, right, is a thing, because this is a skill. Staking it is a skill. Like, here I am chopping this, right? You got to do it correctly. Otherwise, again, if you F up at one step, everything else is going to come out wrong, right? And throughout this month, it's either you get perfect grades or zero. So here's the good news and the bad news is, like, it's easy because it's always 3 things at any given time. So that's nice, man. It always falls within this cognitive range. It's very easy for you to manage. The flip side is, because we're looking for perfect plumbing, a single imperfection means you suck and you get 0. That's just the way logic is, right? And so we're tracking perfection here. And so here we're staking it. I copy paste here. What do we do about these columns over here? That's my template. I've got these columns. What should I do with that? What should I put here? What in the world should I be putting here? Got these extra columns. I just took my template, the grid from the template. It looks like I've got these empty columns. What should I be doing? I'm confused. What should I be putting? You grayed out? No, you delete it. Just delete it. Right click, delete columns. That's it. One and done. All right. So just delete the stuff you don't need. If it turns out that the template provides you with more columns than you need, you just delete it. That's it. Here I'm going to need more columns. I go insert, column to the right. Here you go. Notice that if I say insert column to the left, sometimes it could be gray. Like, I don't know if this is the case here. Let me just say that. Insert column to the left. No, that was okay. But like, suppose you do this here. Insert column to the right. It'll make it gray as well, I think. No, it didn't do that. Insert column to the... Sometimes it can do that. So whatever. Oh, they see that fucked it up. See, there you go. So just do what you got to do to make your grid fit your purposes. Right? So insert column to the right. Here we go. Why do I need 2 columns for my conclusion? Why am I inserting a column? Why did I do that? Yeah, because our animal here is what? It's a negation. I'm going to need 2 columns. I'm going to need a column for my negation sign, and I'm going to need a column for my my M. I actually like copy pasting. You can use your shortcut keys, by the way, but I feel like copy pasting is less liable of error, right? Remember, I told you got to make sure to proof yourself, not introduce errors. If you use your shortcut keys, that's fine, but you might introduce errors where I feel like if you methodically copy paste, there's less chance of you effing up. And I don't want you to F up because I want you to do well. So once I've done this, what's the next step? And I said, never skip that step. My advice as someone who doesn't want you to screw up, better be safe than sorry. So we do what? We proof, exactly. And that's great because we can 30%, like not double check, but like super redundantly check. Everyone have a look. Did I F up? Everything's good? If everything's good, tell me it's good. Because maybe I made a mistake. I'm talking while I'm doing this. We're good. All right, cool. This is good. All right. So let's call this 1, 2, 3, 4, 5, 6. Well, that's not a thing, but let's just call it that. 8, 9, just for fun. Which of these columns am I going to start filling out first and why? Not 3 and 5. There's no way. First things first, right? What do we got to do? We got to fill in our basic truth values for all of the atomic propositions so that we catalog these 8 possible worlds. There's 3 atomic propositions, M, A, and I. So I'm going to fill this up first. Why this? What's so special about this one? Why? Why am I saying this? Why are we going to fill this one first? Some complicated reason? Just because. Left to right came first. That's the first atomic proposition that we encountered, right? Suppose, let's just suppose, for instance, insert column to the left. Suppose that we had this here, right? Which column would we fill out first, the first or the second? Because you just said, Hannah, just because it comes first, should I be filling this first? Which one should we do? Suppose we had this as an argument. We'd be doing the second. Why? So it's not just that it comes first. So just to refine what Hanakwa said, it's the first atomic proposition that we encounter. It's not that it's the first one. So I want everyone to be clear on that. Is that clear? So you fill in the first atomic proposition that you encounter going from left to right. That's the one that you fill in, and you're going to quilt that thing. Type in clear if that's clear. Question if you have a question. It's important, because otherwise you'll be screwed. Everything is sequential. Skip the steps, like you're screwed. Right? It's cool tricks I'm teaching you, but you got to do the tricks correctly. All right, it turns out our argument doesn't say it's not the case that M. It says if M, then. All right, cool. So what's the tempo here? What tempo we're going to use? Filling this up. 4 by 4. So I'm putting them on my caps lock. True, 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 true. False, 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 false. Spot me if I made a mistake. Is that good? Just zoom in a bit more. True, 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 true. False, 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 false. All right, suppose you did this. You did true, true, true. Oopsie. You did this. True, true, true. 5 by 3. You were just going so quickly that you did this. What grade are you going to get on the exam? 0. Everything is screwed. You're done. That was 0. It's graded out of 5. You got 0. Damn. Right? So what's the 0 sucks, we agreed. Therefore, what should we do? Like, you don't want to make a typo like this. Proof, and especially on the way up, because proofing is going to be tedious. You want to proof as well, but also on the way up. So proofs happen after the fact. But what do you want to do when you're doing it? Slow the hell down. Okay? So do it out loud and methodically, because you can easily, I know some of you, you're macho and you probably have a car and you like to speed and you're a risk taker and you're like, I'm smart, I can do this. And you start doing, right? You're doing like this. You want to do fast, right? I'm going to do this super fast, super fast, super fast. And you're going to make all these mistakes and you're going to get a big fat 0 for all that ego. So slow down, right? And make sure you do this step by step correctly, right? It's like walking and never lifting your feet. That's the best comparison I could give you. Logic is like walking and never lifting your feet. Just drag your feet, man. Like, you'll never fall over. Just take it step by step and don't even lift your feet off the ground. T, 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 F, 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 F. All right, fair enough. Which column do I fill in next? What's my next order of business and why? We fill in this one? Kamal says we fill in this one. Do we agree? The third one? Is that what we should be doing? Yeah. Igno's got it. So you want to make sure you've already done M. Do M. Do all the M. Copy paste all that right away. Do the M. You did M, do it right away. Don't postpone that thing. Do that immediately. Kamal, is that clear? Immediately. You put that off, you'll be screwed. And if you're screwed, you fail. And if you fail, I'm sad. And you're sad. And I'm sad. And who wants to be sad? 0 sucks. 0 is the number we want to avoid. Okay, cool. Any more M's? Because we keep going from left to right. Any more M's? No. What's the next atomic proposition that we encounter going from left to right? A. All right, so what's our tempo going to be? We're going to fill this up. For the quilting now, for the crocheting, what's the tempo going to be? 2 by 2. True, true. And we always start with true. Right? So it's not only is it 2 by 2, but it's 2 by 2 starting with true. True, true, false, false. And this is where we want to slow down. True, true, false, false. Then what? We look for more occurrences of A. Are there any further? No. Which column are we gonna fill in next? There are no further instances of A. I. What's our tempo? We're gonna fill this up next because it's the next atomic proposition going from left to right. 1-to-1 tempo. Starting with true, on true, true, false, true, false, true, false, true, false. Don't go that one too quickly. You're going to be tempted to do that one quickly. So remember my advice, right? All right, that's terrific. What next? Well, I believe has learned the lesson. Copy paste, right? Not the conclusion. Oh, Kamal, you didn't learn the lesson yet. Oh, conclusion. Kamal's conclusion. I know it's not a conclusion. It's a second premise. Yeah. Second premise. Paste that thing. Isn't pasting wonderful? Yeah. Yeah, cool. All right, now We got a column underneath the conditional, and we got a column underneath my disjunction. Logically, in order to figure out what's what, there's a pecking order here. There's the law of the jungle. What do we got to do first? Because I want to figure that one out, but what do I have to figure out before I figure this one out? Okay, what's first? The disjunction. Let's zoom in. The disjunction. All right, this is where two knowns, one unknown, right? This is where the drills come in. True or true is? True. True or false? True. False or true? True. False or false? False. That's the one condition under which the disjunction is false, right? True or true? True. True or false? True. False or true? True. False or false? Last one, false or false? False. Wax on, wax off. Can you imagine? All right, so I told you. So, okay, one finger, how many truth values? If you have one atomic proposition, how many truth values? Let's remind ourselves when you're building these grids. One atomic proposition, how many truth values? So I say P. There's two. This could be true, could be false. Two fingers. Two atomic propositions, so times two, how many truth values? Times two for the third finger, how many rows? Fourth finger times two, how many rows? Fifth finger times two, how many rows? Sixth finger times two, how many rows? Seventh finger times two, how many rows? Seventh finger, seven propositions, how many rows? Let's just pause there for a moment. Can you imagine if every time, so you imagine a table, let me insert one. So I'm going to say insert, I'll have a look. Let me just insert table, number of rows, 256, 256 rows, and columns, I'm going to say, let's say 25. Yeah, here we go. Look at that beauty. Can you imagine if every time you had to fill this up, you consulted the solutions because you didn't commit to memory your basic truth tables for each connective? Do you see why Papa Bear had you do those drills to save time? Like you look each time at the PDF, true or true is, and then you have to look over, and then if true, then false. What is that? And you have to look at the solution each time, right? How long would that take you to fill up? Like if it didn't come out quickly like it just did, because y'all are good, you did your drills. If you didn't do the wax on, wax off, how long would this take you? Forever, right? Your nails would grow by the time you're done. Right? Your keyboard would be like, tack, tack, tack. Why is it so loud? My nails have grown. Holy cow. My kids moved out. It's like, right? So we don't want that to happen, right? That's why Papa Bear had you do all those drills, right? So one of the tricks we want to do, because we have two knowns and one unknowns, we're going to figure this out. What are my two knowns? So I said at each time you only got two knowns, one unknown. What are my two knowns to figure this one unknown out? What am I going to be relating? Am I going to say this? If true, then true, true? Should I be doing that? If true, then true, true? Yeah, the antecedent and the consequent, which in this case is this. Let me be absolutely clear. The consequent is here. The consequent is the disjunction. The disjunction, ignore. Disjunction. Yeah. If you did this, do you think that would work well for you? Yes or no? You start, I'm doing it. I got this. I know my drills. I got this. I know my drill. This will not work out well for you. And you'd get a big fat, anybody like donuts? What grade would you get? I'm a donut people. Big fat 0. So, hey man, if you like donuts, you do you. I'm not one to judge. I'll give you lots of them. They're free here. Just do that and guarantee you're going to get some, you'll be in donut land, right? So what we want to do is, here's a trick. Put all this in gray. It's really a cool trick. Put this in gray, right? Now you can see more clearly. You can even momentarily put it in bold, right? You can undo all that stuff after. It's really not a problem. All right, so now we can see more clearly. Let me zoom in even more. If true, then true. If true, then true. And now I'm going to do it, and you stop me if I make a mistake. Look how quickly Papa Bear can do it. Did I make a mistake, yes or no? Say yes if I made a mistake, no if I made no mistake. No mistake, Samuel? Everyone, have a good look. Cool. You look how quickly that went, because I know my drills, right? I practiced. And it's not at the end of the world. All right, so now we filled our whole thing. Then we do what? We have one more to fill up. We're going to zoom in over here. All right, so it's the old flipperoo. So we're going to flip that up. All right, so we're going to false, 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 true, 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 and I'm done. All right? I think I got that right. I think. I'm going to just put this in. Again, all of these colors are unofficial. They're just ways for you to spot. Now, I've got the truth values exhaustively cataloged underneath each main connective for each premise and conclusion. What animal is this? It's a conditional. And now I've obtained all of its possible truth values beneath it. What animal is this? What animal is this? It's an atomic proposition. I've got all of my truth values. And what animal is this? A conclusion happens to be a negation. Now here's a common mistake. What happens, you think, if when you refer yourself to test whether or not this is valid, you refer yourself to this column? Is that going to work out well, or are you going to end up with a donut? Back in donut land, aren't you? And then you'll be like, what happened, professor? And I'll be like, you were actually testing this column. It's like, no, right? So you got to be really clear on your zoology. I'm sorry, little guy, but you got swallowed up by a negation. There's a new boss in town. Now we're going to check for leaks. Let's check for leaks. Is everyone ready? This is fun. We're going to get to check for leaks. We did our work. Type in ready if you're ready. Time to do our plumbing. Time for check for perfection. Looking for leaks. Let's look for leaks. Let's remind ourselves what a leak is. Informally, what's a leak? What would constitute a leak? Because before we know what to look for, like, what are we looking for? What's a leak? It's a situation where what? Not just something being false. More precise than that. There's lots of false stuff. You want false? Here's false. That's false. All true premises are true, right? All the premises are true, right? But the outcome is it. The conclusion is it. Yeah. And watch out. Don't say all the parts. It's all the premises, because you agree that this would be all the parts would be this one, right? Like all the, let's say this is one that has true, 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 all that. That's not necessarily that we want. We want all true premises. You see the distinction, Hannah? Like, we don't just want to always be concerned with the top row, because that's the only one where you're going to all the truth stuff. All the false ones are at the bottom. Yeah. Okay, so let's have a look. True premise. First premise is true. Second premise is true. Conclusion is false. What is this? What am I looking at? What do we have here? All the premises are true and the conclusion is false. What are we looking at? We got a leak. It's an invalid argument, but what we're looking at specifically is the leak that allows us to say that this is an invalid argument. Here's a situation. Let's zoom in. Here's a situation where you can accept the true premise here. You can accept this premise as true, and still the conclusion comes out as false. The world could be such that the reasons claimed turn out to be true, yet the conclusion put forward is false. You're not compelled to agree to this argument. It is an invalid argument. It's invalid. How many leaks do we need to be able to say that an argument is invalid? Notice what I've done. I've put it in red. Right? So we only need one. If there's more leaks, does it make it more invalid? More leaks. It's even more. It's just, now it's horrible. It's less than perfect. Who cares? There's all sorts of degrees of less than perfect, but we're all or nothing here, right? I still want you, this is important, in the quiz, in the test, in your homework, to highlight all of the leaks that you find in your truth table, because it shows me that you did the truth table correctly, right? So let's go for the other rows. This is a situation where the first premise is true. The second premise is false. Are we going to be interested in this row? Yes or no? It's not an interesting row for us. How can I tell whether this particular sink leaks or not? You didn't pour any water in. So the second sink, you didn't pour any water in. All right. First premise is true. Second premise is true. Is this a row that will interest us? Drum roll. We're about to check the conclusion, but will this be one we need to pay close attention to? We kind of do need to pay close attention to. And what's the verdict here? Crap, don't buy that house. There's a leak. It's a leak. It's not that the row is invalid. The argument as a whole is invalid, right? But there's another leak. We have a situation where, right, all the premises are true, yet the conclusion is false. Holy cow. Is this a row that will interest us? A row that has two false premises? Will this be a row that will interest us? Nah, we can skip over that. No one put any water in it. How can we possibly test? We didn't pour the water of truth in those sinks. Will this be a row that we're interested in? Should we slow down with that one and go, ooh, yeah, okay, let's check. And it turns out the conclusion is true. Oh, it turns out the conclusion is true. Does this make the argument valid all of a sudden? The argument is still invalid. We don't know which world we're in. We just want to know whether it's perfect, right? And it suffices to have one imperfection. We don't put any special color coding. There's nothing to do, right? True premise, false premise, not interesting. True premise, true conclusion, but all right, noted, but moving on, right? True premise, false conclusion, not interesting. So now we have an invalid argument, and we can say that leaks at rows 1 and 3. So it turns out it's got 3 leaks. And if you put it in red, you don't need to put it in written. So I don't need you to put it in writing, but I'm telling you here, right? But the convention is you put it in red. In the solutions, you'll see that as well. And then we can know that this is not a valid argument. We still don't know which world we're in because we have to ask who to figure out which world we're in. We're logicians. So who do we pay to figure out which world we're in? Because there's a division of labor here. Who do we pay to figure out which world we're in? Scientists. Good for them, man. God bless the scientists. I love them. They go out in the world and check stuff. They're the fact checkers. Journalists, scientists, natural scientists, social scientists, go and check, right? Gurishanjit, what if you have, let's say, false premises and a true conclusion? Like, who cares? Right? Here's an argument with false premises and a conclusion. Are you ready, Gurishanjit? Right? Let's say, why do I have capitals? Right? Mark is an elephant. There you go. I've got elephants on my mind, right? Mark is an elephant, a single slash. It's false, right? KPU is a space station. Okay? Therefore, the sky is blue. Well, it isn't blue right now, but you know what I mean. There you go. Who cares? Right? You see that? It's this is an argument. It's not valid. It has false premises and a true conclusion. Gersharanjit, you see that would not be super interesting for us. Like we'd go, yeah, okay. Why? Because we'd have a situation where this could be true, this could be false, right? But whatever. Like we don't really care. That would not sort of grab our attention. Does that make sense? That, and this is, by the way, you'll encounter. Yeah, cool. Like we don't care. That's not what we're testing for. Yeah. Samuel writes, so even if there's one row, no worries, I'm happy. No, if there's even one row with true premises and a false conclusion, so all true premises, then the whole table is considered invalid. No, not the table. Let's be precise with our language. The argument would be invalid. The table would be, let's say, methodically and correctly carried out, right? Yeah, yeah. So invalidity attaches to the argument is a property of arguments. Leaks are just leaks. And the table itself is just a table. It's a means of you testing whether or not the argument is invalid. Invalidity is a property of arguments and only arguments. Individual claims cannot be invalid. Rows can't be invalid. The argument itself is invalid because it does not compel its conclusion with absolute certainty. I see. But one invalid row of the table invalidates it. That's correct. That wording, perfectly, you got it. Yeah. And that bothered Descartes to no end, for instance, right? Like if you have a situation where, you have an invalid argument. Yeah, exactly. So look, there's arguments that are, they're probable reasoning, right? So for instance, if I say, and let me give, say, Sally, right, is a mature student, right? And a mature student, and I say, mature students tend to work hard, right? Therefore, Sally what? Sally's a mature student. Mature students tend to work hard. Therefore, Sally works hard. Now, how certain is the conclusions? Is it absolutely 100% secure, the conclusion? You know this 100%? Not certain. It's probable. It's a probable conclusion because I said tends to work hard. Tends to work hard, right? So you want to say something like Sally is or likely works hard or something like this, right? So likely works hard, right? Most arguments are probable. They don't necessarily compel their conclusion that way, right? Deductive arguments are a completely different story, right? Sally is a mature student, right? Mature students pay taxes. And when I mean mature, I mean all mature students, let's say. All mature students pay taxes. Therefore, and let's say you accept those two premises, therefore Sally what? Pays taxes. Now, this follows 100% from the premises, unlike the other one. It's not just a probable conclusion, it's a certain conclusion. If this is true, and if this is true, then this has to be true. You can't just nod yes to this, nod yes to that, and start doubting, well, I'm not sure if she does. If you think I'm not sure if she does, then you got to go back and say you weren't really nodding yes to these two things. I got you compelled into nodding yes for the conclusion. That's a deductively valid argument. What we study in formal logic is called deduction, only the 100% certain stuff. We don't care about the probable stuff. Samuel and everybody else, is that clear? If that's clear, type in clear. If you got a question, ask your question. We're only concerned with absolute certainty. The probable stuff is for the scientists. That's for them. We philosophers also care about the probable stuff. There's three types of inferences. If you did some more epistemology with me or some other stuff I teach you, abductive, inductive, and deductive inferences. We're only concerned with deductive inferences. But yeah, so that's it. Yeah. And invalid is again, it's just a simple property of an argument. It's a situation where not all instances where its premises are true compel you to have a true conclusion. There you go. My friends, it's time to do some work. What do we do now? Well, we're at the end of class. We did absolutely terrific. You've got work to do. Review the step-by-step manual on Moodle. Let me make that available right now. I'm going to click on a magic button. Here we go to week 4. The wonders of technology. All right, here we go. Can everyone go under week 4 and click on where it says the truth table method, a step-by-step manual? Tell me once you've opened that. It should open as a new tab. So you scroll down underneath our wax on, wax off deflecting punches video, which I hope you've seen and enjoyed. And tell me if you can see that. The truth table method, a step-by-step manual. I think it's open in a new tab. Maybe it's downloading. No, it's a pop-up. Is it a pop-up? Not sure. Tell me yes if you can get that. I think it's a forced download. Yeah, you got it. All right, cool. All right. I want you to have a look at that and just do full screen and then page down. It's like a textbook that says everything I said in class today, a step by step, including the sort of, filleting and staking and quilting and everything, the tempo, right down to checking leaks. So the entire process laid out for you as done by Papa Bear, my copyright. Okay, so that's one of the things you want to do. Not now, but maybe now, but again, right? And then what you got to do is obviously, you can't just watch TV. It's not YouTube. do the homework on truth tables, you'll need to use the template. So what you do is you count the number of atomic propositions. If there's 3, you grab the 8 row one. If there's 4, you grab the 16 row one, and so on, and you practice. You do it on your own methodically, and then you check the solutions. If there's one T or F that's out of place, what's your grade? There's a T that just should be an F, or an F that should be a T. What's your grade? Donut. Well, donut do that, all right? It's what it is. It's the nature of the subject matter. The flip side is you're going to bring down everything. Here's an elephant metaphor again. How do we eat an elephant? By stretching our mouths or by cutting it into pieces? Because I don't know about you, I'm not a serpent. How do we eat a mouth? How do we eat an elephant? We cut it into pieces. You cut it into pieces, they cut it into pieces and cut it into pieces, and you could eat an elephant. Because look at the size of your mouth. It's not that you have to fit the whole elephant in your mouth. You just cut it into pieces. Well, at any given point, you're only going to have 3 things to put in your minds, 2 knowns and 1 unknown. You'll have a known here, you'll have a known here, right? And you'll have an unknown that you need to figure out in the middle, and that is it. But everything is going to bring it down to a manageable state. But you need the skill required in order to do that. It's a cool trick that one monkey is teaching another monkey. I learned it from another monkey. Let's keep doing it. Next week, what are we doing? Next week, we're doing a next level skill that requires full mastery of the truth table. So don't fall behind. If you don't practice this week, this really, 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 I'm telling you, will screw up everything. So if ever you want to crack the whip, this is the time. Because next week we're doing something called short truth tables, and they're going to be far more difficult, but at the same time far more powerful and fun. All right? So that's what you got to do. My friends, is everything clear? Type in clear. If you got a question, ask your question. And let me touch base, see if there's questions. Let me touch base with you. We've begun month 2. How did you enjoy this class today? How's class today? Did you have fun? How's this? It's starting to hopefully come together. I want to make it fun and I want to make it manageable, and I'm hoping that you can feel like you can do this. You're liking it? Good? Not too scared? There's lots. I told you every damn minute, right? Yeah. Good stuff. Good stuff. And Edric, remember it for everybody else. The intuitive understanding, like feeling it in your bones, what invalidity is, right? That can wait. Sleeping will take care of that. You need to dream this through. All it is checking for any condition where the premises are true and the conclusion is false. That gives you wiggle room to sort of refuse the conclusion. You can nod to all the reasons I gave you and still refuse the conclusion I'm pushing onto you. That's the wiggle room. So it's like, hey, I've got escape room. That means you didn't present me with a valid argument. I'm not compelled to accept your conclusion. Good, Michael, I'm glad you like the monkey, and I'm trying to make this as fun as possible. And remember all the stuff that we learned today, man. It was a really full plate, right? Russian doll, so that's subsumption. Easy zoology, there's only 6 animals in our jungle. Law of the jungle, understanding what ate what so that we don't freak, right? No matter how big things get, you don't sort of panic, right? You're able to actually do it. And here's the cool thing. Remember this? Hold on. This argument here, right? When we translate it, when we symbolize it, you're going to be able to test this. You're going to build a truth value underneath. P, K, that's 2, 3, 4, 5, 6. 6 atomic propositions is going to be how many rows? 2 times 2 times 2 times 2 times 2 times 2. 6 atomic propositions. 2 times 2, 4, 8, 16, 32, 64. If I got that right, 64. If you make a 64-row truth table, you can test whether this argument, which we started with that was so scary, you can actually now demonstrably prove the question we've been wondering, will elections be triggered? Or like, therefore, either his queen or mine will be exposed. Is this conclusion actually follow from all of this ramble, or is it just BS? Find out on your own in what's called homework. On that note, my friends, I wish you goodbye, and we'll talk to each other next week. Get to work, get to work, get to work. Let's say goodbye and get to work. Let's kick some butt. And I'm not talking about the last test until at least next week, and even then I don't want to talk about it because it makes no difference. Goodbye, my friends. Have a good class. Well, thank you. We had a good class as well. Ignore, terrific work today. Edric, thanks as well. Keep playing around. We're going to do this. Mitrio, good work today. Cole, take care. Samuel, talk to you next week. Indivir, bye. And don't be afraid, Indivir, to say stuff in the chat. I haven't heard much from you, but it's good to have you here. Gersharandri, great questions. I'm glad to answer them. Sayonara, my friend. Spencer, keep at it. Raman, don't give up. Apply yourself. You folks can totally do this. If you can string together two knowns and one unknown, you can do this. Everyone can do this. What's my blurb at the top of the course? Logic, let me read it. Logic is not an IQ contest, but rather a skill like any other that can be learned with practice. So if you apply yourself, I can teach you. Shivam, you take care. Bye-bye, my pupil. I don't know what's the Japanese word for pupil. Sensei is the master. Why do I just know that? Obviously making stuff up. I don't know. Well done, everyone. And have good work this week.